Hey everyone, and welcome to C# 102 Week 4, 3 in the syllabus. It is May 10th, 2012, and today we are going to be covering some interesting stuff. So, yeah. Let's go ahead and get started. If I can get my taskbar. There we go. And Gavin's here, by the way. Hi, Gavin.
Hello. Not that I'm an afterthought or anything. No, that's fine.
Okay, so we're going to recap some things we accidentally introduced last week, namely nested types, and we're going to be talking a little bit more about access modifiers, because we haven't actually talked about some of the interesting access modifiers that we can use in our program yet. So, the first thing we're going to be talking about are nested types. Again, we did talk about this last week, but in C# we can nest types within each other. So you can provide a class or an enum or an interface inside of a class, and you can nest them indefinitely. So I can have child type, grandchild type.
What about struct?
My enum. Yeah, you can add structs in as well. So struct, child, struct. Although we haven't really talked about structs yet.
No, I was just checking that that was why you left it off rather than because they couldn't be.
No, structs and classes can have nested types. Interfaces may not have nested types.
But they may be nested within other types.
Yes.
Or not. Yes.
So the only types that you can nest things are classes and structs, and you can nest them as much as you want.
Well, that was fairly straightforward.
Yes. So does anybody, I know we already covered this last week, we already talked about a potential use case for nested types. Another use case is with like enums, for example. I don't know, let's say we have a person parser, and we might have a parser state enum inside of that type. And this is what we've shown so far, and what we showed last week was the concept of private types. So all of these types inside of a nested type are going to be private.
That's why you've put them inside there. Otherwise, they wouldn't, I mean...
Well, it does get a little bit interesting because once we start talking about access modifiers, because you can actually make these public. But by default, they're going to be private.
Well, it just seems, scoping is the key reason why you do it, so...
Yeah, typically, I don't think I've ever made a public nested type before. Well, I have to do weird metaprogramming stuff with generics. That can be useful, but outside of that, I won't ever create a public type inside of another type, because in that case, I would just make it a not nested type.
Yeah. And just to clarify, on enums, you can nest enums inside of things, as you can see there.
Yes, but you can't nest anything
inside an enum, but it wouldn't make sense to do that anyway. It's weird because I know enums exist at the same level in the hierarchy as classes and so on, but they're much more akin, as you've shown before, to a list or an array or something like that in terms of what they do and how they work.
Mm.
You weren't listening to any of that, were you?
I got a text message, sorry.
Yeah, I know, I realised that. We all heard it.
Let me turn off my phone so I don't get distracted.
That might help.
Okay, so yeah, nested types, very simple concept. So let's talk about accessibility really quickly. Every type has an accessibility or a visibility. Every type, including nested types. you'll notice that both the parent types of this namespace that I have right here, both the types, the non-nested types, they don't have any accessibility modifiers. Neither does on line 10, we don't have any accessibility modifiers on this type either. That means that they get the default accessibility. The default accessibility of a non-nested type is internal. So it gets marked as internal. What does internal mean? Internal accessibility means that this type is only accessible from within the single assembly. If I were to create a class library and reference this assembly, or if this were a class library and I had an internal type and I tried to reference it from an outside assembly, I'll get an error. Internal means private to the assembly, the single DLL or EXE that we are building. I want to point out that there's no correlation between internal and namespaces. There's no such thing as something that's accessible only from within a namespace. That's not possible.
So if you had if you had a class library project within this solution,
yeah,
where and internal was used within that, would it be still available to the console application 16?
No.
So just the project?
Just the project. So if I had a class library, I know we haven't quite talked about class libraries yet, but if I were to have a class library, reference it from this project, and I had a class 1, and instead of, by default, because I've added that reference in on the console application 16, I can access class 1 just fine. However, if I were to change class 1 to being internal, then you'll notice that line 20 becomes an error. This is no longer possible to do.
I just wanted to clarify that distinction because obviously we're talking about in this assembly, and we've touched on those. It has been a while, and yeah. Anyway, so that is really. I mean, are there any questions on?
So this is internal. What internal means? I want to point out that internal can also be applied to methods. So, for example, I can say internal void blah. If this were a public class class 1, and I had an internal method on it, you'll notice that I can't invoke this method from this separate assembly. I can't invoke blah. That's impossible. If I were to try to invoke it from other classes within class library 1, that would be possible to do.
Will it actually, what is the text of the error that it gives you? Will it tell you exactly that?
It'll say, does not contain a definition for blah, no extension blah, accepting first argument. Okay, so never mind. It doesn't detect that it is an internal
I wondered.
method.
Resharper will tell you, or it should tell you, that you'll get an inconsistent accessibility message.
Okay, so what's the difference between private and internal? Private cannot be applied to types such as this. You'll notice that this type may not be private. You may only cannot be explicitly declared as private, protected, or protected internal. So the only modifiers that you can attach to a type that is not nested is going to be either internal or public, or nothing, which turns it into an internal. So both right now class person parser and class program are internal. I can make person parser public if I wanted to by adding the public access modifier, which makes the class public. However, nested types may have different accessibility levels to them, because nested types are different. So unnested types may be public or internal. Those are your only choices. Nested types get... you thought nothing was private. Nothing is private inside of a type. So for example, this enum is private right now. Specifying it being private is redundant, just as if I were to have a field. This would default to private. And so adding the private access modifier in this case is redundant, although it is preferred. I typically like access modifiers on my fields. So you may have members within a class be private, public, internal, protected, or protected internal.
And there is actually a very good video on this that you did. You actually covered this during the C# reference videos.
Mm-hmm.
So if by the time you finish going through all of these you still haven't got it, I'll go and get the link and post it into BuzzNet
Okay.
now.
Wolf says not in structs, right? Structures can have public, internal, and private members, but they may not have protected or protected internal. So let's really quickly talk about protected. We haven't really talked about protected yet. So let's say we have a base type called my base type. A protected member is a member that is private to the enclosing type, but is also accessible from any type that derives from this type. So for example, we may say something like protected void do stuff. Now, if I try to instantiate my base type, I cannot invoke do stuff because the protected modifier acts like private, but with one additional feature. If I have a my child type that inherits from my base type, you'll notice that if I do this dot, do stuff appears. So do stuff is accessible from the child type, but is not accessible from outside of the type hierarchy. Protected it's only useful when you're talking about inheritance, and typically because I avoid inheritance, I don't find myself using this modifier very often, but it does have a lot of great uses, especially when you have especially when you're creating a base type to provide a bunch of common functionality to the children types, but you don't want to make that functionality public. Instead, you want to make it protected to enforce that a person is forced to, or not forced to, but allowed to access it from the child types, but not from anywhere else. So, for example, there's a protected void. Protected can be abstract and virtual, so I can say protected abstract do stuff, and of course I have to make this class abstract. And they may also be virtual. So protected can have abstract and virtual. Private may not have abstract or virtual. So private abstract void hey is a contradiction. And it's a contradiction because hey is an abstract method. That means it has to be overridden in the child classes. By making it private, we're hiding accessibility from everybody down the line of the type hierarchy. Therefore, again, it's a contradiction.
We did have a question come in. What would be good to do to enforce what you... Oh, no, wait a minute. Would be good to do to enforce what you can? Basically, the way I do it, which was influenced by Nelson, and so he can tell you where I've just misread him, is just to make everything as private as you possibly can until you get to a point where you need it to be slightly more public. But try and keep everything as private as possible.
Yeah. Every bit of public functionality you place on a class not only couples that class to a specific implementation of itself, but will also make it impossible to remove that method very easily later down the line if you have a bunch of existing code that relies on that method being accessible.
Was that what you were getting at, Raymond, with your question? Cool. And yeah, if you're asking questions, and you want Nelson to respond, please put them in the webinar questions panel. Not the BuzzNet NATO.
Okay, so let's talk about private versus protected again. Private means that it's only accessible to this type. So this member is private, therefore only accessible to this type. Meaning a method inside of a child type may not access it. this becomes an error. Well, that would be an error anyway. This becomes a more appropriate error. It says, my data is inaccessible due to its protection level. And you'll notice that if I instantiate my child type, that if I do child object dot my data, you'll notice we also get an error here on line 27 because my data is inaccessible. Again, that's actually erroring out for a different reason. There we go. So now you'll notice that my data is inaccessible due to its protection level because it's private in the MyBase type. If I change this modifier from private to protected, one of the errors is going to go away. The error on line 18 goes away because the myChild type now has access to this field because it's protected. However, because it's protected, it still doesn't have public access, meaning line 27 is still an error. Yeah, dot underscore does make me want to throw up, but you'll never be accessing. All fields should be private, period. And if they're public, if you really, really, really want to make a public field for some reason, in which case, if you do make a public field, it should be static and read-only. But if you do make a public field, then I use a different naming convention. But private fields always have the underscore, and as a result, I never have to see this because I never access it with the dot operator.
So what's next?
Okay, so that's protected. Now, internal may also be applied to types or to members of classes and structures. So for example, I can say internal int my data, and now you'll notice that the errors go away. However, because this is internal, no other assemblies may access this member. However, otherwise, to this assembly it is considered to be public, meaning I can access it both in the children and externally. Okay, so we talked about public, protected, private, and internal. You may also apply these modifiers to nested types. Now, nested types behave slightly differently than non-nested types. A nested type, by default, is going to be private. So like I said before, a non-nested type may not be private, and by default, it's internal. A nested type is by default private, and indeed can be private as well. The private accessibility modifier in this case, or the lack of a private accessibility modifier, because private is the default, will make this nested type behave in the way that you'd expect given what the private modifier means, which is to say that only this type can be accessible from within this type. You may also give nested types public. By making it public, you'll notice I can now type in my base type dot nested. So you see, by making this public, I've kind of turned this type into a namespace, sort of, where I'm able to use the dot, the resolution scope resolution operator to reach in and grab a nested member from the my base type, and this is allowed because now nested, this type right here, is public. If it weren't public, if it was private, you'll notice we get a nice little error on line 28 saying that we cannot access this type due to its accessibility level. So internal is pretty much public. It's public to the current assembly. Typically, in larger projects, you will have many assemblies in your solution, many different class libraries in your solution, and then maybe a few client applications, such as a console application or a WinForms application or a WPF application or unit tests or whatever. Unit tests are typically going to be class libraries. The internal modifier is public to the current project that you're in. So remember, if you look at my Solution Explorer, I have two projects, Class Library 1 and Console Application 16. Both of these projects, when built, correspond to a single assembly being generated or compiled. So Class Library 1 turns into Class Library 1.dll, and Console Application 16 turns into Console Application 16.exe. Internal means that we can only access that member from within the same assembly. Okay, so nested types may have any of the modifiers that a member may have. So they may have public, which we saw before, which makes line 28 compile. We have private, which is the default, which throws an error on line 28. We can make them internal, which will make that error go away as well. But remember, the internal modifier specifies that this type's only accessible from within this assembly. We may also use protected. And a protected type, a protected nested type, is going to only be accessible from the base type and his children. So you'll notice that on line 28 we still get an error, but inside this method right there, I can now say my base type dot nested. And I did, for completeness, I did explicitly type this to the fully qualified name, or not the fully qualified, but the type qualified name. But here you'll see that because we're in the scope of the type hierarchy, the my base type dot qualifier is unnecessary. So line 21 is now going to work, whereas line 29 will not. The difference being that this type is a child of my base type.
Are you covering read-only today?
No, that's next week.
Okay.
How would you get code coverage in your unit tests because of access modifiers? Well, if you, let's say you have a public class, and then you have an internal class. Now, in a separate assembly, we may not access this, but we may access this. However, that's not going to stop this type from accessing this type privately. So, for example, I could say public void hey, and I could say var cls equals new my internal class. By doing this, the method itself is invoking a constructor of an internal type, but we can still access this functionality by going through the public type itself. My base type.nested is getting an error on line 41, but it's not getting an error on line 33. The reason is that my base type is a class with a single member, which is a protected class named nested. And because this member is protected, because of the protected modifier added right here, this class is only accessible privately from within this type or privately from within types that inherit from my base type. So you'll notice that line 33 works just fine, whereas line 41 is an error. That's because this program type does not inherit from my base type. If I were to take off this the inheritance of my child type, you'll notice that line 33 becomes an error just like line 41 is, because now my child type no longer inherits from my base type. Okay, so what else is there? We have internal protected. Internal protected is a funny one. Internal protected, it basically combines internal with protected. So basically what this means is I've never ever used internal protected. I just want to point that out. I've never found a valid use case for this this language construct, but it exists. And what it means is inside of this assembly, this member is public. So it works just like with internal. However, outside of this assembly, this type is protected. So again, because of the internal modifier, inside of this assembly, the nested type is public, but outside of this assembly, the nested type will be protected. Meaning that if you wanted to access the nested type from outside of this assembly, you would have to create a type that inherited from my base type. Again, it's a bit esoteric. I've never found an appropriate use.
It would have to be some. It would probably be something where in your assembly you wanted to call something. I don't know. actor or something incredibly generic like that, and you would want to make sure it was public, you wanted it public across your stuff, but wanted to make sure that anyone else's stuff that was using that name didn't conflict with it. I see what you're saying though. It is somewhat, you'd really have to work at finding a way to use it when something else wouldn't be, when it's not redundant.
Yeah. Internal protected, remember, internal protected means in public for this assembly, protected from other assemblies. Or rather, protected for other assemblies. Because protected from actually has a different English meaning than what I intended for. But protected for other assemblies and public for this assembly. That's what internal protected means. So, I mean, I can just throw up an example. It's not really important that you guys understand this, but I just want to introduce it for completeness. Let's say I go into another assembly, my class library 1, and I jump into class1.cs. Let's say I make ble public internal. What this means is that, or sorry, not public internal, protected internal. If I were to create another class, so public static class stuff, and put a method on it, public static void hey, I can do var cls1 equals new class 1 cls1.ble. This is valid. Because this member is protected internal, I can access this member publicly throughout the extent of my class library 1. However, inside of my program class, let's go ahead and instantiate our class 1. You'll notice that ble is not available publicly. Ble is not a public function, or a public method, sorry. So while the right-hand side works, the left-hand side doesn't. So that's the internal behavior of protected internal. The protected behavior of protected internal is that if I were to create a child type of class 1, and I had a method on it called public void hey, or how about whoa, I can invoke ble from here. So this works. This ble function invocation is invoking this function defined on line 19. This ble invocation on line 13 is invoking this function. So these two cases work. I can access this member publicly from within the extent of a class library, but I can only access it in a protected manner on any other class library or application that references this. So that's why line 22 is an error, but line 13 is not.
So are there any more questions on what we've covered so far? Because the question panel's empty, which is great.
So just to recap, child types are 90% of the time, if I write a nested type, it will be private. The other 10% of the time, did I say 95? I don't know. The other small portion of the time, it's only in the case where I'm doing something crazy with generics, and I might make a public type. But we haven't really covered, or public nested type, but I often won't do that. And I typically don't use protected very often, simply because I don't use inheritance very often. But it is useful when I do run across a situation that I need inheritance for.
And one thing I would say is if you're still not sure of what is the implicit behavior of things, specify explicitly. You know, no one's going to be, like Nelson said, no one's going to be bothered by the fact that you've got internal in front of your class, or you've got private int, private field. And if you're not sure, you know, if you can't remember offhand what the particular default is for something, you specify what you want explicitly. Then you know you've done what you intended. And I know that sounds like an obvious thing, but it, you know, I've seen people not doing it. So, what's next?
Okay, let's talk about interfaces really quickly. The interface So for example, if I go ahead and define an interface over here, you'll notice that on over here, that again, that this is going to be a internal, by default it's going to be internal. However, inside of an so the top level behavior remains the same. So for example, up here, this is going to be an internal interface. However, you may not have any access modifiers on any members of an interface. I cannot do private hey or private void hey. This is not allowed on an interface. Everything in an interface is public per definition, which means that everything.
Otherwise you'd never be able to use it.
Yeah. There's no reason to have any other access modifiers on an interface member, and as a result, they are always going to be public. Okay, so what else do we need to talk about access mod? Yeah, that's access modifiers. Super exciting.
I mean, you've all been using these with or without knowing it since day one. This isn't something that is a radical change to the way you've been working.
Yeah.
It's just a question of...
It's something if you... well, it's also, I really want people to start making things as private as possible. Making things private is a good thing. Making things internal is a good thing as well. Sometimes as a consumer of a library, I get irritated when people use internal types. As a writer of a library that will be used in multiple projects, I prefer to use internal as much as possible. Because for every type that you make internal to an assembly means that the likelihood of you breaking other people's code by modifying your internal types is significantly reduced by nature of the fact that they can't directly access those types in the first place.
Wolf asked a good question. He said, what about classes using interfaces, i.e. implementing interfaces? Can they change the public to private?
Interest. That's actually a really interesting question, which I don't. Yeah. Let me. Yeah, this will be fun to go over. Are you sure about that, Segfault? Okay, so let's talk about explicit interface implementation. Now, I know that sounds scary, but bear with me. Okay.
Nice.
Does everybody understand this code at least? I hope this doesn't require explanation, but if it does, it's best to talk about it now then.
Well, it really shouldn't. If people have watched, if the people have actually watched and taken in the previous videos.
Okay. This is called implicit interface implementation. What implicit interface implementation is if you have a public member that has the same name and same signature as a member from an interface that you are implementing, the C# compiler will auto-wire this to be the implementation that's used for this interface. Meaning I can do var item equals new item, and then I can do item.use. I'll take away the implicit typing for now to make this less confusing. And I can also do item2 equals item, and then item2.use. So you'll notice that we only have one object, it being instantiated in main, and that's this new item type. And we're accessing it two ways. We're first accessing it through through a variable of the same type. And maybe it might be nicer if I renamed this to, I don't know, tree. Okay, so we're accessing it right here through line 26 with a variable that's typed to the tree class. And we are able to invoke the use method on it. On line 29, we implicitly convert this variable that's of type tree into a variable of type item. Now, item 2 and item are pointing to the same object, but they have different variable types, and we're able to invoke the use method on item 2 as well. This is how explicit implementation works, because the explicit implementation wires up, or implicit implementation wires up this method to this interface. However, there exists another way to implement a member of an interface, and that's called explicit interface implementation. Now, every single implicit interface implementation must be public. If you're using implicit interface implementation, you must have public members. However, if you are using explicit interface implementation, you must use private members. So to make this an explicit implementation, I take off the access modifier, because access modifiers are not going to be allowed on explicit interface implementations. They must be private at all times. Then you'll notice that I prefix the name of this member with the specific interface that I'm implementing, item in this case.
Are you actually not allowed to have private keyword there, or are you allowed to have null or nothing, or the actual private keyword?
I've never tried it before, but the modifier private is not valid. Nothing is valid. It must be no access modifiers.
Cool.
Okay, so now you'll notice here down on line 27, we get a compiler error. We get a compiler error on line 27 because the use method is no longer a public member of the tree class. However...
Well, no, you've made it private.
Yes. However, we're still fulfilling the interface contract. Therefore, if we were to implicitly convert this variable into an item, we may successfully use it on line 30. So if I comment out line 27, you'll notice that I get a single invocation of the method. So we can still access this member by casting it into an interface. So that's what we're doing on line 29. But we cannot access this member because it is private.
That is interesting, because when you're accessing it via the interface, it seems to magically, it's odd, isn't it? It magically turns it back into a public method.
Yes.
Because you actually do get you use me, which isn't in the interface at all.
Right. The most common use case for explicit implementation is this. Now, I have two options. I can use implicit interface implementation here, in which case the use method will fulfill the contract of item and iStuff at the same time. So you'll notice that if I do a static void use or do stuff with an item, and then a static void do stuff with an iStuff, so let's say I go ahead and invoke do stuff. You'll notice that if I invoke do stuff with item, I'll get a nice little ambiguity, because item can fulfill either do stuff or do stuff, these two overloads. So maybe actually, I was just going to cast it directly, but it'd probably be better if I... So now I can say do stuff on item and pass an item, and then I can say do stuff on stuff and pass an item as well. So you'll notice that if when I run this program, we get, well, I'll take off that line. We get two you used me, because this method fulfills the contract of both interfaces. So item and iStuff.
Two jobs, really.
You what?
I said it's working two jobs, really.
Yes. So you'll notice when I implicitly convert it into an item and invoke use, I get this method implementation, And on line 46, when I implicitly convert it into an iStuff, I still get this implementation. But what if we wanted...
Nelson, what? You beat me to it because of the lag. Go on.
Yeah, what if we wanted to provide a separate implementation for each interface? Well, we use explicit interface implementation. So we'll do void iitem.use. And then void iStuff.use. Now we have two implementations of that conflicting method, and we're able to do so like this. However, because we're using explicit interface implementation, now both use methods are private. And you'll notice that we can combine the both. So I can make one public use method, and then I can make a bunch of private use methods. However, I can't have more than one public use method, obviously, because that would be a compiler error.
And Chris said, so it's like an interface inside an interface?
I'm not sure I follow.
No, I was hoping you would, because I didn't. Well, the same goes for Wolf Knightley's question. I am confused by things.
It is a bit of a weird thing, and I don't use explicit interface implementation very often. The only time I'll use it, let me see, when do I use it? When's the last time I've used this?
Well, see, probably due to the point that Barry just brought up, which is, at that point, why not just make use item and use stuff?
I wouldn't do that. The reason I wouldn't do that is because the method name use is appropriate for item, and I'm pretending it's appropriate for an interface name stuff. And having to change the names of these methods just so these interfaces can play nicely kind of defeats the purpose of an interface, because an interface is a unit of communication to an object, and interfaces should typically be treated as separate concepts. Yeah, main's just down here. Doesn't have to do with this example. Should you write a method a certain way to reduce coupling? Reducing coupling is what you should do.
I think, I don't know, I read that. You need to give clearer examples. More focused examples, perhaps, would be a better way of putting it.
I'm probably just misunderstanding. It seems like you can split up the behavior tree depending on how you cast it, similar to the way you would use an interface to split behavior of a generic object. Yeah. I could see that.
But that's not the... But see, the thing is, you have to remember with this, like Nelson says, he a lot of what he's spoken about already today, he never does. He's never found it useful. And there is a certain amount of this which is here for completeness as much as anything.
Right. Completeness is really...
We are covering the subject here, so you need to know about these things because they do exist. And particularly if you might turn around and see somebody else's code and go, I don't know what that is, or I don't. What does internal mean? I don't. And then this will make. Then you'll have some context for it from this. But if you don't suddenly start looking for ways to use explicit interface implementation in your code, or go looking for ways to,
protected internal, which I've never used.
Yeah, absolutely. And particularly if you've got ReSharper installed.
Yeah, that's actually
it will tell you a lot of this stuff, and this is a lot of Nelson's having a history there from line to line. You hit your semicolon and go, well, why isn't it telling me that this is read-only?
Yeah. I do want to point out, though, that for people who have ReSharper installed, one of the quick hints or one of the little help things you get with Altenor is explicit interface implementation. And that's what it is. That's what this means. In addition, you'll notice that when you use Visual Studio to implement an interface, it'll say implement interface iStuff or explicitly implement interface iStuff. basically, that's just the difference between implicit and explicit interface implementation. So that meaning the item is being cast as item and iStuff, kind of like it was put item as iStuff. Yeah, what's going on here is because this variable is a tree, and at compile time, the C# compiler knows that if you stuff a thing into this variable, and that stuffing of the thing succeeds, then the Visual C# compiler knows that whatever is in this variable at least is a tree. Now, it could be a derived class from tree, but it knows it's at least a tree. And because it knows it's at least a tree, it knows whatever you stuff in it is going to be an object that implements both iItem and iStuff, because tree implements iItem and iStuff. Which is why we do not need an explicit cast right here, because the C# compiler knows that item, because it's a variable type of tree, is implicitly convertible to an iItem or an iStuff. So that's why we don't have a cast.
Yeah, it's pretty much what defines it as being a tree, is the fact that it must therefore also be an iItem and also be an iStuff. Similarly, you could further, like Nels said, you could have a class oak which inherits from tree. That similarly would also be an iItem and an iStuff, but it would be a tree as well, because an oak is a tree, but not. It's that my cat is black, therefore all cats are black thing. A tree is an item, and it's also an iStuff, but not vice versa necessarily.
And I do want to really point out that this explicit and implicit interface implementation is only for interface implementation. This isn't something you would use for, this isn't something you could possibly use for overriding virtual or abstract members.
Yes, I meant to say implementing, not inheriting.
Right, okay, I was just thinking that this was uber important, like this week's homework. It's not uber important, but it's something to learn, something that we can talk about, and it's something that you will come across somebody using, and if you can't read the code, you will instantly be hitting a wall in understanding another person's code.
And Wolf wanted to see main, just briefly.
I think I already...
You haven't... Yeah, there it is.
I did actually pull down when I saw that in the questions pane.
Oh, right, no, so I didn't know that you'd seen it. Well, did you see Andrew's question from way back? Do you want to answer that, or is that...
What about returning a variable type to a nested type from a public method? You'll run into an accessibility problem. Basically, Andrew's question was, let's say we have a class...
The protected internal, I think.
Person, and then a private class woe. Can I have a public method that returns a woe? You'll notice when I compile, I get an inconsistent accessibility, because this is a public method that returns a woe, whereas the woe is a private class. Now, if this were a private method, then this would be accessible. This would work just as well. So because the signature of a public method is public, anything inside of the signature of a public method must also be must be public, at least public. Any item within an internal method, anything in the signature or in the parameter list for an internal method must at least be internal. Same with protected internal, and same with private.
And yeah, NATO, I know, we understood what you meant. Don't panic, people. And Wolf said, I don't think I'm getting the explicit and implicit for the interfaces. Generally speaking, this is something that you will come across it, but there's ways to go about not ever doing it yourself. Would that be a fair thing to say?
Yeah, I've never had a class that implemented multiple interfaces with conflicting members. But if I did, I would be forced to use implicit. Or not necessarily. If I wanted the same implementation of the member to be provided for both interfaces, then I wouldn't. But
well, do you? I mean, you know what explicit and implicit mean in general daily English use. Cool. That's. I mean.
remember, so if I have an interface item with a method called use and a class item that implements item, I have two options. I can implement it explicit or implicitly, where the C# compiler auto wires this implementation to this method because of the conventions that are established in the C# specification, or I can do it explicitly, where I tell the C# compiler specifically which interface method I'm implementing.
But that then makes it private.
And it makes it private. So this method is private. Well, right, if we had an
Gerald
vehicle with a void drive method.
Vehicle?
Whatever.
No, not whatever. It's not how you spell vehicle.
Yeah, so this is explicit and then this is implicit. You can't obviously, well, you actually could. Well, this just, in the existence of, in the presence of an implicit or an explicit implementation, the C# compiler will no longer auto-wire this up to implement this member, because it now is being fulfilled via that method.
So now the public void drive belongs specifically to the item, to the item level of the hierarchy. Yes?
Yeah. It has nothing to do with the iVehicle. Which means if you want to get really confusing, yes, explicit is not public. So if I said var car equals new car, or what did I call this thing again? A vehicle? No. Oh, come on. Oh, I still have it called item. And I said car.drive, and then I said iVehicle car.drive. You'll notice I'll get two different implementations. I'll get the public method for car or for vehicle on line 44, and then I'll get the interface implementation on line 45. Yeah, the explicit cannot be public. Explicit interface implementation may not be public, it may not be protected, it may not be internal, and it may not be protected internal. It has to be private, and there's no way to specify any accessibility modifiers. In main, line 44 will invoke the method on line 16 because we're accessing this method through a variable that's typed to vehicle. But on line 45, we're accessing a method that is named similarly, but actually is a different method altogether, because we're casting car into an iVehicle. So now we're accessing the drive method through the iVehicle name interface, which will end up invoking line 21.
Okay, we're coming up towards about an hour now. I think it would be probably a good time to set something, maybe set up a couple of interfaces and get people to...
Well, see, here's the problem. I can't think of any. I can't. I honestly couldn't think of any example, simply because explicit interface
it's kind of wide-ranging, isn't it? Yeah.
It's not something I've used it before. I can't remember exactly where I used it or why. If I were to use it, it would be because I wanted to implement an interface privately, which sounds silly to do, but I could have sworn I did that one time for a good reason, but I just can't remember what that reason was.
Well, okay. Just leave it, if you split your screen again, leave the whole of that example on screen.
Yeah, if you want to type this out, that'll actually
and then
be...
we can...
Or, yeah, if they want to look at this code. Because although this code isn't... the explicit implementation isn't really hugely important. It is something that I want people to know about. I really want people to know about, but it isn't hugely important. What we have here is a very important concept that is something I want people to understand, which is accessing the same object through a differently typed variable can result in drastically different behavior. That's the most important part of this example. Not necessarily the fact that I was able to implement a drive method twice.
So if you leave that up on the screen, if we take a 10-minute break, and if you've got any more questions that you think of while we're having a break, stick them in the webinar, and then we can wrap this up and move on to what's coming up next.
We're going to be talking about field initializers, conditional operator, and no coalescence, which are all very straightforward stuff. Okay, I'm going to go ahead and hit pause. Resuming. Okay, and resuming. Let's see. NATO asked a great question. Answered and asked a great question, but I thought I would go ahead and point it out. If you were to instantiate a new vehicle and assign it to a variable typed to iVehicle, and you were to invoke the method on that variable that's typed to iVehicle, you will get the explicit implementation. You will get the implementation that you see here on line 21. Because you're accessing that method through the interface. And the interface is only made aware of line 21's implementation of drive. Okay. Well, what's going on is we're instantiating a new vehicle, but then we're immediately turning around and implicitly converting it into an iVehicle variable type. So think about the interface like a gatekeeper, I guess. And we're wrapping this object through the iVehicle gatekeeper. And although the methods themselves do exist on the vehicle class, because we're accessing them through the interface gets to decide which implementation gets invoked. And it's only going to invoke the implementation that we have either implicitly or explicitly told it to do. Okay. So let's talk about field initializers. Field initializers are, not surprisingly, a way to initialize fields. I don't like them. So let's say we have a person type, and we have a private int age, and we want to default it to 10. And then maybe we have a private string name, we want to default it to Nelson. Now, for the purposes of this example, I'm purposefully creating a person class with these specific values.
Yeah, Nelson.
What? What'd I do?
Aliens came to game.
Yeah, I think we may have lost Nelson for a minute.
Hello?
Oh,
You fell off the planet.
You vanished.
Jeez, you scared me.
Is your dog eating your cables again?
No, you terrified me because as I was typing out the example, you're like, whoa, Nelson, in the tone of voice that you would use if I accidentally had typed out something obscene. Like, like I thought,
in the tone of voice if you'd spelt something wrong. How dare you? No, you just suddenly went in from halfway through a sentence like that.
Well, it wasn't quite that bad. That actually hurt my ears.
Was that, sorry? I didn't hear it because I don't hear my own.
And it looks like I'm not the only one.
Yeah, well, that's Nelson's fault.
Oh, you're missing. Oh, that's right. You're not over in IRC, are you? I mean, BuzzNet.
Oh, I sneaked back in.
Oh, okay, yeah. So
during the break.
You're getting feedback then.
okay.
Yeah, well, now Nelson knows what happened.
So for the purposes of this example, I am creating a person class, and the definition of the person class, I do want these fields to be defaulted to the values that I've specified. Sound good? I don't want people saying, well, wait a sec, why are you assigning 10 to the age and name Nelson to the name? Because that's not particularly good design, but I'm saying that this is my design. This is the behavior that I want. And what I'm doing here is I'm using what are called field initializers. And field initializers allow us to initialize fields to a value, to an expression.
Oh, I'll tell you what you could do for this example. Instead of age, you could use, you could have two, you could have stats, you could have XP and level.
Yeah, or maybe health. Health defaults
Well, I was just
to
thinking
100.
of something, because, yeah.
And
that'd be good.
mana defaults to 200. And then I could have a, then I could have a method called public void take damage int damage health minus equals damage. If health is less than 0, then console write line
Less than or equal to, surely.
less than or equal to. And then I'll probably invert it, actually. I typically like that style more.
Yeah.
Okay. So, field initializers look like they're a great way to set default values for your fields. And indeed they are. You get a lot of neat things with them. You get fully fledged expressions. So for example, something like class name, public name string value. I could say, something like private name equals new name Nelson. So we get the full power of an expression that we can place in here. But the problem I have with field initializers, and I mean, at least field initializers, really simple concept. Really simple concept. We are automatically defaulting these values to
Default values.
yeah. Are there any questions about so far?
Well, Segful had a nice question there, but I don't know if that'll lead into where you're going next.
It is going to. Okay. Any questions about what we have here? Very simple stuff. You can use the equals operator and you can assign it to values. Okay. My problem with field initializers are that...
You should,
Yeah?
did you intend to not finish off line 12 and 13 and so forth? Or did you just get...
It's not relevant for the example, but I guess I could. I just wanted to point out that you can actually do instantiation. It's not like a constant where you can't use an expression. You can use expressions.
Mm-hmm. So Nelson, why is this bad?
Oh, somebody does ask something. Can you assign a field value using a method call? Yes. For example, I could say private int test return 4 private int whoa equals, or at least as far as the methods inside of the class you won't be able to, thankfully. And that's a very nice thing, although we will see in a second ways that you can do this. But if this were a static method outside of the class, for example, if I had a static class whoa and a public static int getInt method, we may invoke this static method. So I can say whoa.getInt.
And that'll set underscore whoa to 4.
Yes. So let's talk about some
Does that have to be...
No. Is that
silly question. No, silly question. Carry on.
Okay. Few problems with initializers. First problem is I think they're ugly. I just really...
Well, yes, but go to Start with Segfault's question, because I think that's quite a good way into it.
Well, okay, let me go ahead and set up an example then, because this example is going to lead into the number one thing I hate about field initializers. Let's say getInt string from getting an int from blah from, and then we could also, so now we can say getInt into woe, getInt into mana, and I'll qualify it too. I'll say person.mana, person.woe. And what I'm doing here is basically making it so we'll actually be able to watch the execution as it happens. So now when I instantiate this object, when I say var p equals new person, we get this. We start with health, then we go to mana, then we get to woe, then we get to the constructor.
Mm-hmm.
So, some problems I have with this code. First of all, again, I think that field initializers personally are ugly, because typically having executable code outside of a method really can get confusing, because fortunately, you are guaranteed to have field initializers invoked before constructors. But unfortunately, the order of those field initializers aren't going to be necessarily defined, especially once you start talking about partial classes. In addition, you won't be able to rely on any existing state of the object to calculate the default values. In addition, you have code, executable expressions that are sitting freeform outside of a method. So you really, you lose it. You lose control, not necessarily at a level in which it is in the specification that field initializers run before the constructor. That is something you can be guaranteed to happen. But conceptually, you don't get that same feeling, because, for example, I can do this private int down here. Not that I would, but I could, and I run this code, and you notice we still get the same behavior.
And will it, presumably, it will go top to bottom through the initializers in the order that you do them?
The Microsoft,
or is that not even given?
That's not a given. The Microsoft C# implementation does, and I presume the Mono does as well. Just because, it's probably, for each member in class, emit code that sets default initializers.
Yeah. But if you hate this so much, is there a better way of doing it?
Well, yeah, use a constructor.
Yeah.
Use a constructor. This code really gets difficult to reason about, because it doesn't have any. Again, it's a C# expression that's evaluated that isn't constrained into a method. So especially if you're new to programming and you're looking through a class that has a bunch of field initializers, reasoning about the order in which things happen becomes very difficult. So they do get just tacked on into the constructor, kind of, sort of. It gets a little bit more complicated once we start talking about inheritance, which we will be. So basically, I think they're ugly. I think they make it possible to write freeform code outside of the constraints of a method. I think they lose readability. They have fewer features because you cannot invoke methods within the class itself. And furthermore, you cannot depend on any data that's going to be in existence to calculate the value. So please just set these in the constructor. Set health to 100, mana to 100, or to 200, and woe to 4 inside the constructor. Now, again, that's my personal distaste for field initializers. Again, they really don't lend well to clean code, in my opinion. If you want to use them, they're a valid feature of the C# language, and you're more than welcome to. But there are some caveats that are very important to keep in mind. Ooh, well, static ones have precedence. I'm going to get to static field initializers in a moment, because static field initializers are kind of fun. I mean, fun in a way that's kind of annoying. The only time I will use a field initializer, I'll use a field initializer in two scenarios. For a static read-only field, and for a synchronization root object. And a synchronization root object is used for the lock construct in C# for multi-threading. Because that's kind of out of scope, I don't really want to talk about it, but what it would look like is something like private object sync root equals new object. I would use a field initializer for that, because the fact is I'm just creating a dummy object anyway. It doesn't really have any important thing. And I'll use private static read-onlys, or public static read-onlys in certain cases.
Meanwhile, back at 102.
So let's talk about a problem with this code. Notice how, I'm going to delete the name class because we don't really need it anymore. Let's go ahead and write a base. And do private int base stuff equals woe.getInt base.base stuff. And then I'll write a public base constructor, parameterless constructor, and I'll say woe getInt from base ctor. And then from here I'll say from person ctor. So if you place health last, will be outputted last. It will typically, unless you have a partial class, and that behavior should not be relied on. It's not a consistent thing that you can rely on in your code. You should never think of field initializers executing in any specific order. Okay, when I run this code, what's going to happen is we have two constructors that will be invoked, our base constructor and our person constructor. And that's, of course, after I make person inherit from base. Then we also have these private int fields that are being initialized to this expression that invokes the woe.getInt method, which, if you recall, prints something out to the console so we can watch things as they happen. So when I run this code, we'll notice something a little interesting. You'll notice that it says getting an int from person.health, person.man, and person.woe. These three initializers were executed first. Okay? Then you'll see getting an int from base.base stuff. Right? So this initializer then gets invoked. Then you'll see getting int from base ctor, which will be this. And then you'll see getting an int from person ctor, which is this. Does anybody notice a problem with the order of things coming back?
Yes.
Anybody other than Gavin or Segfault? There's a very unintuitive issue with the order that this code is executing that isn't immediately obvious and can bite you in certain circumstances.
And it's slightly more specific than what Segfault just put, I would say.
Yes. Okay, so constructors are invoked from the base constructor to the child constructor. Fields are invoked from the child class to the base class.
Hence we get this sort of strange bouncing order where it does the person initializers, then the base initializer, but then the base constructor, and then the person constructor.
Yep, it's backwards.
Boo.
This has the potential to be problematic in certain cases when working with virtual members. However,
over and above just messing with your head.
Yeah. The problem is it's difficult to reason about the code, and you always want to be able to reason about the code. The fact is, if you use field initializers and constructors and inheritance, you might never run into a problem. It'll still look ugly, it'll still be gross. I personally wouldn't like it. You're free to do so. However, when you reach a bug, when you mix virtual members with inheritance and field initializers that you can't figure out, remember, it's probably going to be to do with the order that the code is executed.
There's a certain amount of code as if you're assuming it's going to break, I find.
Yeah.
If you start going, yeah, that's messy, but it works. Okay, it works at the moment, but if it does break in the future, then you've got to come back to a mess to find your way through it again.
Right. So how do we fix this? Well, it's easy. Let's take our field initializer and stick them in the constructor. Now when I run the code, you'll notice the order that things probably should, well, let me get the order to be consistent first. The order that things make more sense in. The first line of code that's executed is the base constructor, line 24. Then it goes to 25. So we get getting an int from base.baseStuff and then getting an int from base CTOR. Then we get the person's constructor, health, mana, and woe, and then finally getting an int from person CTOR. So this order is something that's acceptable.
And yeah, you can just see it makes much more, it's a much more logical grouping. Everything to do with base happens, and then everything to do with things, and if you had something else that inherited. You see, you have to remember, we're giving, even with this tiny example of one thing that is inheriting one from one other class and is only being used in one place. It's all happening within program at the moment. The program.cs. It rapidly gets very confusing.
Right. And you should always basically, like I said, the situations that this will actually really become problematic are a bit contrived. If you're using some virtual member invocations and base constructors, you'll run into situations that aren't very ideal. However, the fact is you should always be able to reason about your code. That's one thing that I always like to represent in the code that I write, is you should be able to reason about it. You should know when things get executed, when things aren't getting executed, what order it happens in. Otherwise, if the order is undefined in your mind, then things become difficult. And even for me, reasoning about the order in which fields gets initialized is something that would confuse myself if I was working with a particularly large inheritance hierarchy, which consequently I never actually write, but still. And again, if you want to use field initializers, you are more than welcome to. They're valid constructs of the language. A lot of people use them. I just find them distasteful personally, and I avoid them, except for in the two exceptions that I mentioned earlier, which, again, were private sync roots and private static read-onlys or public static read-onlys. Okay.
So any more questions about that before we move on to something else?
Yeah, because the next two things are going to be pretty straightforward. Then we just have a bunch of BCL to talk about, a simple design conversation, and then homework.
Yay.
Yeah, all the code is basically just going to be what you see right here.
You taught it to us, and then you told us not to use it.
Yes. Well, I didn't. No, I didn't tell you not to use it. I said you're welcome to use it, if you want to.
But we'll hate you forever if you do.
I just don't like them. I personally don't like them. This is just one of the things seeing the biggest problem for me isn't the inheritance thing. That's an irritating problem that does actually irritate me, but it isn't the biggest reason why I don't use field initializers. I do not like the fact that you can have code floating around outside of a method in a class. I find that difficult to reason about and difficult to change in the future, because it's very likely that if you are initializing a field, it's very likely that even if you don't need any data from a constructor argument or a computation from a private method, that eventually you will. And so you'll have to put it in the constructor anyway. Yes, JetBrains has been working on a decompiler for many months, ever since Reflector went all gay. The 1.0 version's just come out. I've had the preview build on it for a while.
Back to the lesson.
Okay. Ternary operators and null coalescence. Very scary words, very simple operators. let's say we have, well, here, let me go ahead and just paste bin this, because I think that might be easier.
Paste bin?
Or GitHub this. I meant GitHub, or gist this. I'm gisting it. I don't paste bin. Paste bin's for old people. Paste bin's for people who use SVN.
Old as in 35. And Segfault's not old.
Okay. Let's talk about Ternary. Ternary, very straightforward. Let's say that we have, let me think of an example. It's something I use so often that it's hard to pick a specific example. Let's say that...
age restrictions for buying alcohol.
Well, sure. Okay. So var age equals 22. And then I could say console right line age is greater or equal to 21. There's a ternary. Super exciting. Okay, what this code is essentially...
the long way.
Yeah, I was about to say.
Write it out the long way as well.
This code is essentially doing this.
Just an exclamation point. Just another exclamation point. That's a resharper thing. Andy Smash.
Okay. So, what the ternary is it's like this. It has 3 operands, which is why it's called the ternary. Remember, we have unary. For example, I can say if not true equals false. This is an example of a unary and a binary operator. So the true equals false is a binary operator, because the operator is this, and it takes in 2 operands. A unary operator takes in 1 operand. As you see, the explanation point, the not operator, is going to negate this expression. As a result, it doesn't use anything to the left of it. The ternary is called the ternary is because it has 3 operands. We have the condition, we have the true expression, and we have the false expression. If the condition is true, the true expression gets evaluated. If the condition is false, the false condition gets evaluated. Now, this is very important that the 2 expressions will not get invoked if only one of the 2 expressions will actually get executed. So this literally does translate into this code. This code between line 14 and 21 literally gets translated into line 25.
Basically, it looks at the first chunk of the first operand. If it's true, it returns the second one. If it's false, the first one's false, it returns the third one.
Yep.
And that's it.
That's it.
And I've seen you write it out before where you've got long things going on. You line it out, and I find that a lot easier to read myself.
I'll generally go for something like this.
It just makes them stick out a bit more,
Yep.
obviously, and you can see what's related to true and false.
Okay, some important things. The operators must be implicitly convertible. Meaning, you must be able to, or the operands must be implicitly convertible. The type of the expression that's used for the condition must be a Boolean expression, just like what you would see here on line 14 inside the parens in the if statement. There must be a Boolean expression, true or false. However, the other operands can be any type as long as they're implicitly convertible to each other. So you'll notice that I can't do a string or an int in a string. But if I were to do an int and a double, this would work, because an int is implicitly convertible to a double. That means this entire expression becomes a double, and I can prove that by doing this.
Yeah, because it will give you back a double.
Yep. So if I hover over var, it says this is implicitly typed to a double, because the C# compiler found the best match of making both of these types similar. So the types must be homogeneous. You can't have two types that are inconvertible to each other. So you can't have a in 43, or because of that's an integer type, that's going to be convertible into an int, and as a result we're going to get a double. But you couldn't have a string a, for example, because a string a is not convertible to an integer value. As a result, it is not convertible into a double value.
Which is logical if you think about it. What all of this is saying is check whether something is true or false and give me one of a pair of answers. It makes no sense at all to not know what type you're going to get back from that. You would always expect to know.
Yep.
What you would expect to have a particular type come back. Therefore, if you can't convert the true option and the false option, then you have no way of knowing.
And then you obviously, because both of these must be expressions that return a value, you may not do something like age is greater or equal to 21. Even this won't work because you can't have free-floating expressions in C#, but you couldn't do this. And there's two reasons why you can't do this. First of all, I'm not assigning this expression to anything, but even if I were to, because console.writeLine returns a void, there's no way for these expressions have no value.
And Chris brought up, can you do a pass on the string inside the ternary? Or ternary, which is fantastic.
Well, you could do this. This would work. And the reason this would work is the int.parse method returns an integer, which means this entire expression is typed to an integer. I don't understand why the console write line can't do string and int. Because C# is a statically typed language. Every expression must have a type. And you must know...
Well, put it in...
You what?
Well, I was going to say, if you put lines 25, 6, and 7 into a method call, how would you know what return type to give it?
Yeah. So if you wanted to return this expression from a method, which return type would you use? Would you use an integer or would you use a string? The types must be homogeneous. There's no way to do it. Does console.writeLine have a var? .writeLine have a var? I don't understand.
It doesn't have a return type, so you couldn't assign it to anything. You couldn't say var line equals...
Right, I couldn't say var ble equals console writeLine. And the reason I can't do this is because console.writeLine is void. Cannot assign void to an implicitly typed local variable. Remember, that void is a type in the context of the C# language. Void is not a type that's going to be represented at runtime.
Void is to types as black is to colors.
Yeah.
It's an absence of type. It's conceptually that way.
I don't... Are you asking if you can... The assignment?
I don't understand what he's asking.
And the argument. You can't use implicit typing inside of it. Well, in a way, this is a form of implicit typing. This is a form of implicit typing because we're not explicitly typing anything. The C# compiler is determining the most appropriate type given the two options. And when they're the same type, that's easy because it'll just use a string.
the format of a ternary is always going to be bool, question mark, and then some type, colon, and then the same type.
Yep. So Chris asks, so it only works with any two expressions that are interconvertible, including a non-void method calls? Yes. So for example, if I had static int stuff return 4, then static double whoa return blah blah blah, I could use method invocations inside a ternary and I'll get a double back. So I'll get var dbl equals age greater or equal to 21 stuff colon whoa. Remember that an expression, any expression can be put in here as long as it is not void. I mean, console.writeLine is a method, right? So it's an overload issue. Well, no. Remember that when the C# compiler goes to emit, and when I say emit, what I mean is when the C# compiler goes to generate the corresponding intermediate language for this line of code. So when the C# compiler goes to say, okay, I have determined that based off the specification of the language, the user was intending to do this. Therefore, I need to print out these following opcodes for the CPU to run. When it does that, it has to choose a specific overload of console.writeLine at compile time. There's no way for, after compile time, for you to change the overload that you're going to be invoking. Which means that the C# compiler must know the one and only type of this expression. If this expression has multiple types, it's not even valid to have an expression with multiple types. But if it did, if that was something you could do in C#, then how would C# know which overload of writeLine to write? Would it write the int overload, or would it do the string overload? Because it has to choose one. When the C# compiler goes to generate the opcodes, it chooses a specific implementation of console.writeLine. And that means that every single argument we pass into console.writeLine must be of a particular type.
It might make it a little clearer if you broke that out into a variable, what you're writing.
Right. This is equivalent if I had done this. I don't know.
Line.
Okay, Florm asks, if I wanted to do this, would it be acceptable to do this instead? And the answer is yes and no. You can do this. What I'm doing here is I'm converting this into a string. However, if I wanted to do this, I wouldn't append an empty string to it. I would simply write that.toString.
But that type of thing you can do, yes. Essentially, it's a question of what happens in what order, as much as anything, which is why I got Nelson to break that out into a separate variable, because obviously that variable assignment happens before the write line. Even when it's inline there, that gets evaluated before the write line happens. And similarly, that toString there on line 23 happens before the evaluation.
Right.
Or rather before the assignment. By putting the toString there, you're guaranteeing that there's going to be a string type coming back, which is why the error goes away.
So remember, C# is a statically typed language for the most part. There is a way to get the C# compiler to decide which overload to invoke at runtime, but that's using the dynamic typing features of C#, which are way out of scope. But typically, you would want to use, when using C#, you should always use static typing unless you're doing something very specific that requires you to use dynamic typing.
So have you got...
Okay, so does anybody have any more questions about the ternary? Very straightforward operator, because what we're going to go into next is even more straightforward if you understand the ternary thus far.
Binary.
So is the ternary 3 things? What are the things for 2 things and 1 thing? This
binary and unary.
Yeah, this is a binary operator because it takes in 2 parameters, 2 operands, and the not operator, the explanation point, is a unary operator. Can we nest ternaries? Yes, you can go crazy with ternaries. So, for example, you could do if age equals greater than or equal to 21. Then we could also do age is greater or equal to 100.
Oh, and incidentally, one with 4 variables would be called a quaternary, which ties into something that Nelson, you and I were talking about before, the origin of the word quaternion.
Oh, yeah.
It's got 4 things in it.
So, yeah, you can nest ternaries as much as you like. I do really want to point out, however, that I would actually not write code like this. Just because we're wrapping up this example, what I wouldn't do instead is I would say this. This is how I would write this particular bit of functionality.
Yeah, because you've identified the fact that only one thing changes.
Right.
You can express it in a way that only one word changes.
Can I do stuff, bool, stuff things? Yes. I mean, well, no. I don't understand the question, actually. Let's say stuff took in a string. I could do stuff.
No, that is a string stuff. That is an actual literal string that he's wrote there, and so is thing.
Yeah.
So yeah, you can do that.
So this is acceptable syntax. Okay. No coalescence time.
Yeah, no, this isn't. This is not anything specific to do with console.write. Then you just use that as a simple example to have some thing to put one in.
Yeah. Okay, let's go ahead and talk about
Null coalescence.
yes, null coalescence. Okay, null coalescence, very straightforward. Let's say we have a class account. Can I spell null coalescence? No. It's right here.
And sake for, I got that joke the first time and it wasn't funny. That's why I didn't laugh.
Well, that's coalescing. Okay, so no coalescence. Let's talk about, let's say we have static account, get account, and then let's say we have a private int account ID or logged in account ID, and we set this like 42, and of course it must be static. And then we might say try to get a, or let's say account count equals try to get account from database using logged in account ID. And I'm going to set it to null for now. And maybe we have a private static account not logged in account that we initialize to Okay. So very simple example so far. We have a class account with a public string name property. We have a private static account, not logged in account for when we're not logged in. I initialize that to a new instance of an account and say not logged in. So we'll just use this as a placeholder for code that when we're not logged in. Then I create a private static int logged in account ID. I set it to 42. And then I write a method called getAccount. Now getAccount, the behavior that we want is if we can get the account from the database, return the account gotten from the database. If we can't get the account from the database, return our not logged in account that we have. So we can go about it a few ways. We can say if account does not equal null, return account, otherwise return not logged in account. Does this code make sense to everybody?
Mm-hmm. All of a sudden, I've just been thinking about this, and it's like Terminator.
Terminator?
Yeah, it's just like really. Is it Terminator 2? I can never remember which one it is. Where it comes back together from all the little bits.
Oh, right.
Of Mercury T2. Yeah. It's that sort of coalescence. Anyway, sorry. Random things.
Okay.
Somebody said, "Won't it always be null?"
Yes, but that's because there's a comment there saying we're imagining there's database access code right there. Come on, use your imagination.
Yeah, what that's saying there is that what he's explaining now is how we do what he's commented there.
Okay, so then we're saying if we couldn't get the account from the database, or if we could get the account from the database, return the account. Otherwise, return a not logged in account. Well, we could simplify this. We could say something like return account does not equal null, question mark, account, colon, not logged in account. This would perform the same operation using the ternary that we just discussed. It'll return the account variable from the database if it was retrieved. Otherwise, it'll return the default not logged in account. However, in regards to ternaries, this sort of operation happens so often that the C# language introduced a nice little shortcut for it. So instead of doing this, we can do this. And now you should all get Segfault's joke. This is synonymous with this. The null coalescence operator is a binary operator that's more or less, or actually not more or less, it's exactly just going to check to see if the left operand is null. If it is null, it'll return the right expression. Otherwise, it'll return the left expression.
Yeah, you're literally saying, give me this if it exists. If it doesn't exist, though, I don't want you to blow up or throw an error or give me null. Just give me
something
what
else.
I say is the default. Yeah.
Are there any questions about no coalescence?
And as you can see, both of these, null coalescence and the ternary operator, are both shorthand ways of doing variations on a theme. And it's because you know so much of program is involved in, well, if this is the answer, do this, otherwise do something else. That you would end up writing so many ifs and elses that they actually programmed a quicker way of doing it.
Mm-hmm. And yeah, that's about it. Yeah, kind of like open or create. If you can open it, do so. If not, create.
And you might have something like, if book is in stock, return the book, otherwise put in an order for the book. It can rapidly get more complicated, the situations in which you can use this.
But I do use null coalescence and ternaries where appropriate, and I will start actually using them during the examples to shorten up some code.
Chris, yeah, kind of like an open or create. If you can open it, do so. If not, create it. It's exactly the same principle.
And Wolfast, so it's asking if it's not null. Yes, that's all it's doing. Remember, this line is equivalent to this line. Exact same thing. But it doesn't make it null, it just asks. Yeah, it just asks to see if this is null. And if it isn't, it returns this. If it is null, then it'll return this. Yes, it saves you a whole 4 characters.
Could you tidy away line 34 now?
Can I what?
Tidy up line 34.
What, just say this?
Yeah.
Or I could just do this.
Cool.
Okay, so it's...
Have you got some fancy example for them to work out to do with these?
If you come up with one...
I was going to say give them some longhand code and get them to convert it, or vice versa. In fact, a bit of both would be good.
Yeah, something like... Well, an H thing. Like, for example... Well, we already did that, though. What else would I... I don't know why I can't think of examples anymore. Okay.
No, good. That's not a horrible method name, NATO. Very, very good method name.
Okay, so something like...
Tells you exactly what the method does.
I'm drawing a blank. So how about just this? If 8 greater than 100.
Oh, well, how about, you know your example from the previous that printed out 175 downwards? Is that where you're going with this?
No, I'm just going to have this. So yeah, so go ahead, get this down to one line of code, and preferably use format strings. And I'm going to go ahead and pause the video. So we are back. Let's go ahead and factor this code into a single line. It would look something like this.
Would you want to do it? Do you want to go do it in a two-step process?
What would the first step be?
Build the ternary first. Well, this is...
Well, yeah.
To explain what you're doing, how you're doing it, because it's not... You could just magically say this equals this. That's the answer.
Okay, so that's how you break it down into a ternary. At this point, now we need to take this expression and inline the variable. And to inline the variable, we can simply take what we're assigning to and simply assign it to, or place it inside the ternary. So if you didn't see what I did, I cut this expression out and I placed it where the variable was being used. And then at this point, I would probably format it. I would leave it like this, but if it got particularly long, I would first format it into this, and if it got even longer, I would format it into this. Or, sorry, this.
Yeah, I was wondering, but I thought, okay. I thought C++ formatting was infecting your brain.
So yeah, so that's going to be how to get this down to a single statement. Any questions about that bit of code? Because then we're going to be moving on to some BCL, which is going to be all very straightforward.
Someone did ask, is there any way of including a prompt on the same line, in the same?
Yes,
Like,
but not.
your age.
So
And take. Sorry, I was just going to say, and take note. That is one line of code
yes.
from 12 through to 16. That is one line of code. In terms of executable code,
Yeah.
10 through to 17 is all. There is only one line of executable code, which is that one that starts at line 12.
And this style of programming is really, it really meshes in with the functional style of programming, where you sort of treat your program like one giant expression, and you composite values together in your expression by using things like a ternary or no coalescence. So getting used to reading this kind of code and knowing the order in which things execute. Now, what's going to happen is the first thing that's going to execute is this. And when I highlight that and I say this is going to execute, what I actually mean is this string literal will be placed into a string variable. That's going to be the first thing that happens. It's not going to be printed out to the screen yet. Then this is going to happen. The getInt method is going to be invoked. Once the getInt method is invoked and the result gets replaced here, then the ternary happens. And one of these two values gets sent into the second parameter of writeLine. So at the end of the day, what this will turn into is either, so the first step is the first parameter gets sent in, and then the ternary gets executed, or not the ternary, the method invocation gets executed. Once the method invocation gets executed, the ternary gets executed. So these are the steps that this line goes through until all that's left are values being passed into parameters of the writeLine method. At that point, the writeLine method is going to be invoked. Okay, any more
I think
questions?
this probably is simpler to understand, generally speaking, than
Again, yeah.
a lot of what we've covered in the 102 course so far. Because again, this is back to syntax. This is syntax that we're explaining rather than concepts, which can get quite nebulous and tricky to pin down.
Right. So basically, yeah, like Gavin said, we're doing two things with this course. We're talking about object-oriented design, and we're talking about features of the C# language. The features that you use to implement a method are up to you, and it's completely different to how you orchestrate your code, and that has to do with design. So this is just a new feature that you can use to represent logic, and then when we get into design discussions, that's when we start talking about how to organize your code.
And something that Floram just said is something that I've been trying to get across all the way through this course. He said, NATO, I would suggest doing a few of those converts from if to ternaries to get used to it. And yeah, if there is something of this that you feel like, okay, well, that's the explanation, but I don't get it. For all, in the name of all that is pony, open up a console app and play with it. Try using it. See what you can do with it. You're not going to destroy the internet unless you're like really Lee or Matthew Broderick.
Okay, so now let's get on to the BCL. We've already talked about the dictionary last week. I kind of snuck that in, and I just launched the wrong instance of Visual Studio. We already talked about that dictionary last week. So let's talk about the hash set. Now, you'll notice, first of all, that if I do system collections.generic, you notice we get a bunch of nice little types here. We get our dictionary type, our hash set type, we get our linked list type, our list type, our queue type, our sorted dictionary type, sorted list type, sorted set type, and sorted, or not sorted, stack type. So
Well said.
let's talk about the hash set. Now, what is a hash set? Okay, the hash set is...
I am not allowed Beavis and Butthead moments when... Excuse me, pony boy. Carry on.
A hash set is a collection that can only contain one unique value. Or it can only contain unique values, sorry. It can contain 0 to infinity unique values of the given type that you have. So for example, we can do set.add 10, set.add 20, and set.add 10 again. And then we can loop over it. We can say for each var item in set, console write line item. Given the definition I just gave for hash set, what is the expected output of this program? Can anybody take a stab at the expected output of this program?
I have a feeling you're trying to trick me.
Okay.
But I don't have VS up, so I can't check it.
I'm going to go ahead and hit a 5. We get 10 and 20.
If you rewind the video, you will hear the word unique.
Yep.
In Nelson's definition there.
A hash set is not a list. It is a set. And a set, typically speaking in programming, is going to be a set of unique values.
Yeah, it's mathematically a set. Or rather, it's a mathematical set.
Yep. So when would you use a hash set? Well, one way would be to very efficiently find duplicates in a list. So for example...
no.
What?
Sorry, I thought you'd finished the sentence. No, it doesn't. The type that's in there is not relevant to the discussion. It could be something else.
It could be a person, for example. So let me go ahead and create a list.
The other question that came in with a quick yes/no is it multi-dimensional allowed in a hash set?
I suppose you could do a hash set of hash set, but that would
No, I mean, could you have hash set of int, comma, string, comma?
You can do a hash set of tuples.
How many parameters?
It only has one generic parameter.
Can you have hash set, int, comma, something else? Right.
It must be a single type. Okay, so let's go ahead and use a hash sets functionality to remove all of the duplicates in this list. We want to find all the duplicates in this list and add it to the non-dupe list. So let's go ahead and do that. What I'm going to do is I'm going to write a for each loop for each item in list, and then I'm going to say if set.add item non-duped.add item. Now I can say for each var item in non-duped console write line item.
That's interesting then. So the add actually returns a bool.
Yes.
Is that the case for lists? List.add?
No.
I didn't think it was, but I wasn't sure.
This is the functionality that we get with hash sets. And the great thing about hash sets is they're very performant in finding duplicates.
That adds an item to the set.
Yes.
And returns whether it was able to do so or not.
Yep.
So if you try to add something, well, set.add item evaluates to true or false It either managed to add the item, or the item was already there, so it couldn't, or for some reason other, it couldn't add item. In which case it will return false. So therefore you can perform an if on it, because it evaluates to a Boolean. The important thing when deciding what you can put in there is the return type. If you hover over add, you should see the tooltip pop up. If Nelson was listening, he would have done that by now. There we go. And the important thing is the first word there, bool. That is the return type of hash set.
Yep.
Cool. You get it now.
And if you go ahead and look at the remove method, you'll also see bool remove. And that will return true if it actually removes something, false if it didn't. Hash sets may not be indexed, so you may not use an index with them. But you can for each over them. Hash sets are called hash sets because they use the get hashcode function that's available on every object in .NET to determine equality.
Actually, that is a good question. Have you actually explicitly been over the the list initializer yet?
I don't think so. That's next week.
I know we've used it a few times in examples, but
Okay, so that's the hash set. The hash set is very useful for determining if something has already been added. That is its primary use.
well, Wolf, if he wasn't passing it through the hash set, if he was just printing out, if he was just adding each item in list to the second one and to the other list, you would get the same output by printing the list. You would get 100, 100, 2, you would get all the values. When he ran it just then, you saw it. He only had 4 results because there are only 4 unique values.
Yep.
2, 5, 313, and 100.
And hash sets are...
That is the difference.
Yep. And you might be wondering, well, what if you used a dictionary, for example? Or what if you looped... Because basically, otherwise... I didn't actually need the hash set here. I could have just added them all directly to the list and then looped over it. But I hope maybe I didn't actually explain what I really wanted at the beginning. I specifically, for this example, I wanted a list of non-duplicated items for whatever purpose that I might have.
Oh, you did say that.
Okay. So I specifically wanted this. I could have just done this, where I just say set.add and then loop over the set. That would have given me the same result, but I specifically wanted to show how using the set.add return value will allow you to pass that value or determine uniqueness. So getting unique items is the only reason to use them. No. Well, yes and no. You use a...
Not uniquely.
You use a hash set whenever you have a set, whenever you want to represent a set of unique values. That's when you use a hash set. Hash sets are very efficient in doing this. The internal implementation of the hash set algorithm provides a very efficient way of doing this that's more efficient than if you had used a dictionary, and especially more efficient if for every time I looped over an item in list, I did another loop to determine if an item has been duplicated or not. It's a very efficient way to determine equality. And you can use hash sets in a variety of ways. You can use hash sets to kind of be a gatekeeper into a function to make sure that it's only been invoked with specific parameters one time at the very least. You can use it to represent a list of, like just what I said, you use it to find uniqueness, to find duplicates, and use it to either remove duplicates or to print out duplicates. So for example, if I wanted to find every value that was duplicated, I could have, instead of non-duped, I can set duped. And then I can say if not set.addItem, duped.add. And this will return everything that's been duplicated.
I just love the name non-deduped that you got there momentarily. That's a fantastic name for a variable. And again, this is the sort of thing where you shouldn't be going looking for opportunities to use these so much as being aware of them being there so that when you want this functionality, you know that this is what you use.
Right, and there are many problems in programming that require knowledge of duplicates. And this is how you do it. You use the hash set collection.
Have you got a rough idea of how much more performant than it is?
Significantly. On a break, I can look up the specifics on it.
I just wondered, is it like orders of magnitude faster? Like you say, don't panic now if you haven't got it to hand. But, although, like Crossman says, where do you look up those things?
Google. Okay, or just do your own performance testing. Okay. So, can you do set equals non-duped? I don't know. No. I can't assign a hash set to a list. That isn't an assignment that is valid. That being said, I can pass a list into the sets constructor, and I can pass a set into a list constructor, or list into a set constructor. No.
Yeah, you can do it both ways around.
Yeah. So, for example, I could have done this. I could have said set.addItem and then I could say var non-duped equals list of set, or list of set, or yeah, that. This would work. But again, I just wanted to show the if check on the set.add. Why do I do the second loop with the list and not the hash? Purposes of example. Again, the example is that I wanted to send in a list and I wanted to return a list. I was just using the set to perform the intermediate operations.
Barry said we could use it on a list of rooms to ensure the names are unique instead of a GUID.
Yeah, so for example, if you had a class room with the public string name get private set, public room string name equals name. Of course, that's not what I wanted. I hate overwrite. And var rooms equals new list of room. Roomies. So if I wanted to write a function that would send me back a list of duplicated rooms, I could say static list of room get duplicated room names list of room var set equals new hash set of string for each var room in rooms set.add or hold on var dupes equals new list of room, and then I could have just done if not set add room.name dupes add room return dupes, and then I could say something like for each var duped room in get duplicated rooms console.writeLine room blah is a duplicate. So now I get room hey is a duplicate. Yeah, the code is just going to be, it's basically just a DTO at the top, and then I have a the implementation of the function at the bottom, or the method.
Is that how much more are you going to cover any of the more methods on that, or is that pretty much what you wanted to cover?
Well, there's nothing else that's really interesting. Let's see what else is interesting. We can count. Hold on, let me nuke link for a second so it doesn't get cluttered. Find, that's fine. And that's not, it takes in a delegate, so we can't really go over it. For each will take in a delegate as well, so we don't want to talk about that. Remove does what you'd expect and returns a bool. Reverse does what you expect as well.
I'm intrigued by seeing remove all there. Oh no, that's on the list. That's why.
Yeah.
Sorry, I meant about the.
Ooh, that is on the list.
set.
Why was I not looking at the hash set? Derp. I was like, yeah, that's weird.
I was looking at that. Why has it got like remove last and things like that? There is only one.
Yeah.
Anyway.
Okay, so we have add clear contains. Yeah.
Sorry, I just saw what Craftsman wrote in BuzzNet. He said, "What else is interesting? We can count."
Yeah. And again, it's not a.
Wow, Nelson, maths is really your forte.
It's not a super exciting class, but it is very useful when finding duplicates. Because typically, if you don't know about this class and you try to find duplicates, you'll end up doing nested looping, which will be highly inefficient and ugly.
And Florum just pointed out, I imagine this is the case, that most of what you're dealing with, like intersect, if it has got a mathematical definition to do with set theory, it's probably going to be set up to do the same thing as you would do in maths.
Yeah. Modifies the current object to contain only elements that are present.
So you can use it to do Venn diagrams. It's really cool.
It's funny, I didn't know about that method because I used the link intersect method that works just as well. In fact, all these methods should, like, things like intersect with, or accept with, or contains, all of these things are part of link anyway.
But maths got there first, you see.
Well, because they didn't have link in early versions of .NET.
They didn't have computers in early versions of maths.
Okay.
So cool. Next.
Queues. Gavin, read the last word of the question that came in.
What hash set? Yeah.
That's funny. Any add method in can behave like a conditional operator, or only in hash set. Typically, hash set's the only one that's going to return a Boolean. Am I going to use hash set in BuzzGame anywhere? I reserve the right to. Again, remember, this is a C# 102 class. We're going over a lot of features of C#.
Yeah, this isn't a how to make a game class. We are making a game purely as a coherent, long form example to use. That is not the central point of what this class is about. This is about teaching you object-oriented design and some little bits and pieces of .NET syntax.
Right, and you're free to use them in the way that you see fit, and I encourage people to use them in the situations that they're appropriate to be used. Okay.
Circular dependencies.
Oh, yeah. Circular dependencies are dependencies that are circular.
And that argument is an example of a circular dependency.
A circular dependency is when one class A depends on class B and class B depends on class A, which you can do in C# without problem.
And you can end up doing... It's easier to end up doing that than you think it is by accident, because it's not doesn't necessarily have to be direct like that. You can have class A that depends on class B, B depends on C, C depends on D, and then all of a sudden in D you try to depend on something from A.
Right. I will give anybody here $1.
A whole
A
dollar?
whole dollar. If without modifying either of these classes, they can properly instantiate them.
A whole
dollar.
Do you say improperly instantiate?
No, properly instantiate these two classes without having to modify the class definitions themselves. Without using casting either, because that'd be cheating. Basically, this is an example of a circular dependency. So if I try to instantiate an A, I need to pass in a B, and without using null. Can't use null. I can just do this all day. And of course, we get a nice little error right here. So yeah, so that's an example of a circular dependency in the form of a constructor parameter. Okay, anyway, so let's talk about queues. Queues are easy. Queues are basically just going to be a way to queue up items. I mean, that's all it is. So it's going to be a first in, first out collection. And that's really it. It's not that special. It's very good to use queues when you are trying to represent a queue of operations, for example, or something. So let's say we had a queue of...
What methods are available on queue? Have you literally just got a push and pop, or...
You don't get a push and pop. You get a NQ and DQ.
Same difference.
So basically what I can do is I can go and say NQ file 1. I can continuously queue up items.
I noticed you've got a peak in there, which is quite nice.
Yeah. And then I can do something like while file names count is greater than 0, string file name equals file names dot DQ, console write line processing blah. So you'll notice processing file 1 through 7, and then I can
greater than equal to.
Oh. Was it greater than equal to? Oh, right. No? Yes. No. What?
Should be, surely.
You're confusing me, Gavin.
Oh, okay, you're deep.
Okay.
Yeah, I'm confusing myself. Sorry.
So when you in-queue an item into the queue, it gets added to the end of the queue, and then you can continuously dequeue items. A dequeue not only removes a first item from the queue, but also returns it, so you get some really nice looking syntax. So it's really...
Do you want to go over peak as well while we're here?
Oh yeah, I mean a peak...
It's quite straightforward.
There's also a peak method. A peak will return the object at the beginning of the queue, but will not remove it.
It'll tell you what's next, really.
Yep.
like in Tetris?
It allows null values. It allows duplicate values. It's also very efficient. It's more efficient for storing a queue type operation than a list would be. Because a list, whenever you remove an item at the beginning of a list, you have to essentially recopy the entire list into a new list. So it's a very inefficient thing. The queue is appropriate for this sort of operation.
I was going to say, with things like hash sets and queues and various other sort of things like that, conceptually, is it good to view them as sort of speciality lists that have been tuned to do a particular thing particularly well, rather than a list which is sort of a catch-all? It can handle, a jack of all trades can handle everything, but not very efficiently necessarily.
Yeah, it's all about what I want people to take away from this discussion is when you're using a list, think about what other data type you could use instead. You could use dictionaries, you could use queues, you can use stacks, you can use hash sets, and they're all going to be appropriate substitutes for a list, given that the situation that you have calls for them. So when you do queue something, it returns the value, then removes it from the queue? Yes. Do I find myself using these specialty types more often than I use lists? It depends on what I'm doing. I probably use dictionaries.
You just use IEnumerables with everything.
Yeah. As the backing type, I generally use dictionaries as a specific thing. I generally, in my public APIs, I will use IEnumerables consistently. So IEnumerables, we'll be talking about IEnumerables later. They become very important. Link works with IEnumerables, which is, consequently one of the reasons why I use them. And then when I have a very specific thing, like let's say I have a list of messages that I want to queue up and send to a client, I would package that up in a queue. Or let's say I was trying to find duplicates, I would use a hash set. If I was trying to relate two pieces of data, I would use a dictionary. I probably use a dictionary more than I use a list directly. Now, I do end up instantiating lists all the time, but not directly through using link. Yua?
I was just thinking another, queues would be very useful if you were writing some sort of music processing thing where everything's got to happen in a specific order.
Right. And so I could have like an interface I operation void exec, class print stuff, public print stuff string message, private string message I operation message equals message console write line message, and then something like class push new op I operation public push new op queue of I operation. So now what I could do is I can say queue of I operation, and I can say let's enqueue ops.enqueue new print stuff, message 1 and message 2, 3, 4, and then maybe I would want to then enqueue a new push new op. I want to interrupt the queue as it's running and push something new onto it. And then I can go ahead and do message 5 and message 6, and then I push another push new op. Now I can say while ops.count is greater than 0, I can say ops.dequeue .exec. And when I run this code, you'll notice the behavior of the queue. So what happens is when print stuff gets invoked, we get message 1 through 6. But then during the operation of the queue, we enqueued new stuff to do while we're processing the queue. And you'll notice that because this is a first in, first out collection type, you notice that these things get appended to the end of the queue as they get run. And yes, the enqueue method is like an add.
There are a few people asking about whether you could like remove from the other end, pull from bottom.
Yes, but that's a different type. That's the type we're getting into next.
So no, then.
Well, yes.
Why do you do that? No, you can't, then.
Well, you can't, but you can with a different type.
Yeah. You never ask the question that's asked. Answer the question that's asked. Yeah.
Can you look at it with an index? No, you cannot. Why would you want to look at it with an index? Because these specialty dictionary or specialty collections don't provide an index operation, that gives them the flexibility to implement its logic in any way that it wants. You wouldn't, per definition, if you wanted to use a queue, then you wouldn't want to access things by index just based off the fact that you're using a queue and not a list.
It's all about using the right one for the right situation.
You may use a for each with a queue, although I typically avoid using a for each with a queue.
Why?
It doesn't feel right.
Okay. Oh no, if that's the answer, that's fine. I just wondered. Anything more specific?
Does using for each unique everything? No. Queues are not necessarily going to be unique. You can have duplicate entries in queues, and you can have null entries in queues. So what's going on here is that if I set a breakpoint on line 57, you'll notice that our ops queue has 8 operations in it. A print stuff, and then a few more print stuffs, then a push new op, then a few more print stuffs, then a push new op. And you'll notice as I dequeue and execute, you'll notice this happens. But watch what happens. Look at this. Okay, so now the ops is 5 items long, right? Now it's 4 items long. But watch what happens when I execute this operation, because this is a push new op. You'll notice that it says ops.enqueue. When I hit F11, what happens here is that we now have 4 items on, but the print stuff goes to the end of the queue. So that's why when we look at the code, the 2 things we pushed on in the middle of processing the queue were handled afterwards. So it's well, the idea of a queue is that whenever I invoke enqueue, that's going to add it to the end of the queue. Enqueue is like the add method for a list. Dequeue is like the remove at 1 at the list. Or remove at 0. Index 1, but value 0.
Or vice versa.
Well, I mean, it's the first index, but it happens to be 0.
First index.
No, a for each loop is not going to remove anything from the queue. So if I had done for each var op in ops op.exec, you'll notice, well, first of all, I can't actually invoke that. I can't invoke the push new op because the push new op is going to modify the collection during the for each loop, but it's not going to be destructive. Well, basically, every time that we loop over these 3 lines of code, we are first dequeuing an item. So we're taking an item that's at the top of the queue, and we're removing it, and then we're returning it. So we're basically doing this. I operation op equals ops dequeue, and then op.exec. Now the I operation interface has two implementations. It has the print stuff implementation and the push new op implementation. So either this exec method is going to be invoked or this exec method is going to be invoked. The first iteration of this loop is going to dequeue this guy, message 1. The second iteration of the loop is going to dequeue this guy. The third is going to dequeue this guy. The fourth is going to dequeue this guy. Now the fifth iteration of the loop is going to be interesting because it's going to dequeue this item, but you'll notice that the implementation of the exec method that's invoked actually pushes something new onto the end of the queue. And that's the important thing. While I was processing the queue, I pushed on a new operation. And the important thing to notice is that operation goes to the end of the queue. So that's why we get this output. We get message 1 through 6, and then at the end, because we get message 1 through 6 because of the line on 23, this exec method. And at the end, we get a few more print stuff operations because during the execution of the queue, we invoked ops.enqueue twice.
Cool. So what's next?
Stacks.
And then is that it for the BCL stuff?
Yes.
Cool. Let's get through stacks then.
What did I do that for? Hold on. Let me run this. I'm going to go ahead and take a screenshot of that, I guess. And then I'm going to redo all my changes. Okay. So, this is the exact same code. One using a stack, which is a first in, last out, and one using a queue, which is a first in, first out. You'll notice the difference in the code is that we started with these guys, then we went to message 6, and then to message 5, and then to another guy, then to message 4, 3, 2, 1. When we had queues, we went from 1 to 6, and then the last two. So a stack, you can push and pop and peek a stack. A push pushes the item to the top of the stack. A pop removes the item from the top of the stack and returns it.
I'm with Wick.
Yes.
You'll appreciate that too, Nelson.
Yes. It's just like the stack in Magic, where if I was to respond, if I had priority and I was to respond with the spell I cast would go onto the stack, and then priority would switch to the player opposite of me, and he would have the opportunity to cast a spell. Now his spell would go on top of the stack as well, and the stack would keep on getting larger and larger with different spells, and then once nobody had a response, those spells start executing in a first in, first out, or first in, last out order. Yes, they resolve.
Chris's question.
Stupid question. When you pass your ops to your push new op, you never hand the queue stack back. How does it take into account the new operations? That's a good question. What's happening is a stack is a class. Because stack is a class, it is considered to be a reference type in C#. Meaning, the operations that I pass in is actually a reference to this variable. Or not to this variable, but to this object. Remember, this object is allocated on the heap for us. It's available to us outside of the context of our primary bits of memory that we get to work with. And when I copy it, the reference into the push new op constructor, this operation field is assigned to the exact same object as this operation local variable, because this stack is being passed around by reference. Top is a little confusing, as in the start or the top. It can be looked at anyway, either way.
Yeah, which is the front of the queue, which is the... Basically, if you concentrate on a queue is first in, first out. And a stack is first in, last out.
Well, here, you know what? I'm tablet time. I probably should have done this first, but now is also a good opportunity to do it because now we've talked about both of them and talk about their differences.
Yeah, it's clearer to see.
That's a big brush. Okay, so... Come on, Nate, I'm not that bad.
Oh, you are. To be fair.
Oh god, how do you spell Q?
Q-U-E-U-E.
See, I know how to spell not well outside of typing, but when you actually have to think about the letters, it's awful. Especially with weird-looking words. Okay, so we have a Q. And a queue is going to be when we add an element to a queue, it's just a list of things. So we have thing 1, thing 2, and this could be a number, an object, an interface, an enum.
People in a post office.
Yeah. Okay, when I add...
I mean... and I didn't mean that facetiously. If you think about that, that is exactly what a queue is. The first person who walks into the bank, you know, you join the queue and the first person to join the queue gets to go first. That's why it's called a queue, as Atomizer pointed out. Stack doesn't really have that correlation with the real world. But you can just remember it by opposite, if you see what I mean.
There. So a queue, the add operation of a queue adds a new thing to the end of the queue. The remove operation from the queue takes something away from the beginning of the queue. This is the enqueue method. This is the dequeue method. A stack is the opposite. An add operation is called a push. A push pushes something on top of the queue. The remove operation is called a pop. It takes what's on the top of the stack and removes it. Ah! Whoa. What? Are you... What?
Hit escape. I think you must have hit Control-T by mistake.
This is not... I'm not touching anything right now, basically, and this is kind of freaky. I'm not even touching the wheel, and the wheel's set to scroll right now.
Have you got, are you team viewed up?
No. Don't. Stop. Photoshop really despises me. Maybe it's my wireless doohickey wigging out.
Did somebody use the microwave upstairs?
Yeah, there are random keystrokes entering my computer right now from somewhere. I'm going to go ahead and...
Probably the beer you spilled on it the other night.
No, I didn't spill beer on the tablet. I spilled beer on the keyboard.
keyboard. Exactly.
And Wick said, NATO. So, about those whiteboarding lessons. Yes, it does.
Okay, so let's see if I could... Oh, there we go. Okay, so now that I'm plugged in now. I think it was a wireless thing wigging out. Okay, and then my start menu appears. Okay,
I'm about to die, I think.
what do you mean?
Blue screen is about to occur unless my graphics hardware magically comes back.
It's been nice knowing you, Gavin.
See you.
Yeah, this hasn't...
See ya. So anyways, go ahead and continue.
Okay. Yeah. So we have our stack and our queue. The queue, the add operation adds it to the end. The remove operation removes it from the front. The stack, the add operation removes it or pushes it onto the top. The remove operation pops it off the top. Again, for those of you who may play Magic the Gathering, if I were to, so I could have player 1 and then player 2, if I was to cast, let's say I cast a creature, that creature card goes onto the stack. Now, priority switches over to him. He has an option to do something now. And what he can do is he can counter. So he can go ahead and put a counter spell on top of the stack. And then priority then jumps back to me. I can optionally respond, and I can say, well, I don't like his counter spell, so I'm going to counter his counter spell, which does happen. I've seen 3 counter spells on the stack before. And then, at this point, he has option again, but let's say he doesn't do anything. So then the stack starts to unwind. So the first thing that happens is my counter happens. My counter removes his counter off the stack, so it pops his counter goes away. So his counter and then creature. So my counter executes first because it's at the top of the stack. My counter takes his counter and destroys it, removes it off the stack, and then finally the last thing that happens is my creature resolves. 7 counters. That's funny. There's actually, it's actually such a real problem in Magic that there's a card that specifically, essentially breaks the fourth wall and says, okay, if there's 3 things on the stack right now, you can cast this card for free and have it remove the entire stack completely. It's in Zendikar, I think. But anyway, so this is a real-world example of a stack. How every action that I took and he took got pushed onto this stack right here. And then, when nobody had any more responses, it executed things line by line. And that's what happens here. So how are people feeling about the stack and the queue?
Looks like we're in pretty good shape.
Sweet. Okay, so jumping back into Visual Studio, there's one last thing kind of on our list, although actually we've been going for quite a while now, and Gavin might be back here in a few minutes, so maybe it would be a good time to quickly take a break.
Yeah, we can take a break. He's back.
All right.
We can take a quick
Go
break
ahead and
if you want
hit
to.
pause. Okay, and we're back. We're going to wrap up today with a really important concept that actually does have a little bit more discussion involved than SRP, like what we had last week. We're going to be talking about the open-closed principle. Now, the open-closed principle is actually commonly not used in the right context. It's commonly misunderstood by people. Now, the open-close principle is the O in solid. It follows single responsibility principle in solid. And what it is essentially is objects should be open for extension but closed for modifications. Now, here's the thing. A lot of people take that to mean that objects or classes should be inheritable and should make a very wide usage of virtual members. And what I said was open-closed is that code, classes, functions, and stuff should be open for extension but closed for modification. And the word extension there, people commonly think inheritance. So they commonly think that, for example, making a sealed class will break open-close principle. But it's actually a lot more in depth than that. Basically, what the open-close principle is about is it kind of goes hand in hand with the concept of write-only code. Write-only code is a term that I've seen coined recently in the last few years. It might be older than that. But what write-only code means is that you aren't allowed to change code, with the exception of bug fixes. But you are not allowed to change existing code to implement new features. So for example, let's say that we have a class that really breaks the open-close principle.
Is that really the best name for that, Enum?
Huh?
Is that really the best name for that, Enum?
It could be selected room.
Well, no, because I mean, there's more rooms available. Sure, I mean.
What do you mean?
Well, it's not. I mean, the current room is actually the current room. So it's.
Well, yeah. So I could.
Not it's an enum of. It's an enum of rooms that are available.
Room ID.
Yeah.
Okay, so I can move to room 2 or move to room 3, and of course it doesn't actually work. Hold on. Why doesn't it? I'm being stupid.
What did you type? I didn't. You typed so fast I didn't see what you were typing in as input.
Move to parts. Oh, pff. I'm dumb. Derp. I was reassigning current room to room ID 1 every iteration. Okay. Simple program. Let's say, for sake of example, that the output and functionality of this program is correct.
It does what we want it to do.
Yes.
But can we make the code better?
Well, let's talk about what's wrong with this
code. Can we do it in a better way?
Who here can easily say in one sentence what's wrong with this code? Oh. Can anybody easily say in one sentence what's wrong with this code?
Hey, well, you did give the caveat that we should be assuming that the functionality is correct.
The problem with this code is it is a complete violation of the open-close principle. Complete and utter.
I like NATO's answer best.
Yeah.
I want another room.
Yeah. Okay, let's imagine what we would have to do to add another room. That's one modification, two modifications, three modifications, four modifications. This is not...
And bear in,
what?
And bear in mind that it just so happens here that he's nested the enum inside the class. If that was a separate enum on its own, it could quite easily be in a separate CS file, it could be in a separate namespace. You could start having to go all around your code into different namespaces, into different changing code everywhere.
Mm-hmm.
And I've done this. I had this problem a few months ago with something. And that was, well, it's worth pointing out what that example was, because it will bring home the sheer scale of the horror. This was in dealing with input, hotkeys, and so forth. Now, if you ever considered how many things you can press on a keyboard.
Yeah. And thinking about...
It's a huge amount of work that you're creating for yourself by writing code like this.
Right. And the way that it breaks open-close principles, we had to modify code in order to change functionality or to add functionality. Now, Barry says those look like adds to me, not modifications. The fact that I had to reach into this class to change it is a modification. I want to be able to add a room without modifying this object at all. I want this object, I want to be able to write this object once, I want to test it, I want to make sure it doesn't have any errors, I want to make sure it follows SRP and has one responsibility, and then I want to leave it alone forever and let it collect dust. Because I don't want to reach into this object to modify every time I need to add a room. Not only does that clutter your code significantly, but you have the opportunity to completely mess up your already tested code. This is a gross violation of open-closed. I do want to stress right now that, especially in a language that has supportive interfaces, open-closed doesn't necessarily have any correlation to inheritance whatsoever. The open-closed principle is about making write-only code. And write-only code is basically when you want to add a new feature, you should be forced to create additional classes and additional methods on new classes, and not be forced to modify existing code, or at least minimize the amount of existing code you have to modify. Because for every bit of modification to existing code, you introduce the potential for bugs. So, this is horrible code. How would we fix it? Well, quite easily. What we could do is we can identify a commonality in our data, or in our data model. And the commonality in our data model is that we have rooms, and they all have names, and we can move to a room based off the name. So let's go ahead and write a version of this class that follows the open-close principle. I'm going to collapse this and write a class good game. Then I'm going to write an interface called iRoom. I'm going to give it a name, and I'm going to give it a display method. The good game is going to have a private dictionary of string and iRoom called rooms. It's going to have a public good game constructor. And then it's going to have a run method just like before. But here's what's going to go on. We're going to have iRoom, current room, and actually we're going to take in the first room as a parameter to make it even more flexible. And then I'm going to say while true, we're going to say current room.display, and then I'm going to actually steal this input code because I won't type that all again. See, there.
Wow.
There, Gavin.
This has never happened, ever.
Okay. So then I'm going to say I room next room, and I'm going to say if rooms.tryGetValue parts1 out next room, then I'm going to say current room equals next room. Finally, I'm going to add a method called addRoom that takes an iRoom room and says rooms.add room.name room. Raymond asked a great question. Does the open-close principle apply to both public and private objects? Typically speaking, I put significantly less weight on the integrity of the design of objects that are hidden behind a common interface. Once I've abstracted my code properly and created the proper interfaces to represent what I want to do, I will care less about the code that actually goes behind those interfaces than I do the code that interacts with those interfaces. So I typically will put less weight on the good design when talking about private classes, internal classes, and classes that are just used for implementation purposes. Now that doesn't mean that that's not a free card to just go crazy and break every single rule all the time, but it's about where do you allocate your time as far as design goes. Do you allocate it to creating reusable abstractions that will save you lots of time in the future? Or do you sit down and spend 2 hours fixing up a method that's only ever invoked, a few times, that exists as an implementation detail and not as a design? That being said, good design does include open-close principle, as it does SRP. So I would typically want to think, and especially at this stage for people who haven't really done much OOD yet, I would want to encourage everybody to make everything as proper as they can. And then later down the line, you can start choosing what parts of the code you want to spend the most time on to optimize design for. Okay. Without actually seeing any running code, because here's the funny thing. This class doesn't do anything yet. I just wrote a class that does nothing. It doesn't have any functionality in it that's important to us, really. Besides the input handling code, which really should be in its own class anyway, but still, it doesn't really do anything all that interesting. However, because of the open-close principle, now what we can do is we can now extend the functionality of our program and add as many additional features, as many additional rooms as we want in a write-only fashion, where we're only writing additional code, we're not modifying existing code. So the way that I would use this game is I could say, okay, let's write a basic room. And the basic room will take in a name for his constructor. And the display is simply going to say console writeline in room blah. So then I can say var gg equals new good game, gd.addRoom new basic room, room 1.
I have a slightly random question that just occurred to me then.
Yeah.
Which isn't specifically about this, but there on line 126, you're still referencing the property.
On line 126? Yeah.
Sorry, I'm being dumb because it's an auto property. But if it weren't an auto property. Yeah, what I was going to ask was in terms of accessing from within the same class. If you actually had a fully written out property there with a backing field.
Yeah, in that case.
Would you typically access the backing field?
Depends.
When you could.
It depends. I would prefer to use the property if it had a public setter or a private setter. But sometimes I might want to bypass that if there's logic in the property that I specifically, knowingly, and want to bypass. However, I would keep that down to the minimum. I would use the property as much as possible.
Okay. And NATO, all it was, it sounded more convoluted because halfway through asking, I realised that he was using an auto property, which doesn't give you access to the backing field. But just ignore what I was asking about.
Okay, so now I can move 1, move 2, move 4, move first, or sorry, move first, capital F. Move first. Oh. See, I never added the first room. So move 4, move first, move first. There we go. Move 1, move 2. And finally quit.
Yeah, it was definitely the shouting and typing harder that made that work.
Yes.
Nothing to do with the capitalization. Well, that does bring up a good point, though. That's the sort of thing that you've really got to remember to make sure you check for. Those are the sort of things that are bugs that get through. Failure to check like for like.
Yeah.
Normally in production code, you would be checking to lower invariant. What's it called? Invariant?
Yes.
Yes.
Or using the you use the equals method with a doohickey thing. I mean, I can actually construct this dictionary with a string compare dot invariant culture ignore case, and now the dictionary is case insensitive. So now I can say
nice.
Move.
Although we haven't got into comparers
first.
That's a bigger discussion.
Okay. And Musaru, I hope you never deploy your code to Turkey. Okay, so basically...
Yes, no Christmas code for you.
Well, it's true. What is it? Their K character won't work with the dot to lower. But there's more than that.
Sorry, sadly, my knowledge of internationalization is not quite where it should be.
Yeah, dot to lower to compare for case-insensitive strings is bad. Okay, yeah, I can send this code to you guys. But what we have here is code that actually does follow. Yes, C# is all UTF. But that's not the problem. The problem is it's different. We'll get into that at some point. Okay. What we have here is a write-only version of our same class. This class will not get larger unless A, we start fleshing out the input handling, although the input handling should be abstracted itself. So this bit is actually breaking the OCP right here. But this class will not get bigger unless the responsibilities of the class change, in which case we need a new class itself. Or you add a responsibility to this class, in which case you're breaking SRP. Or you're adding to the input handling code logic, which, again, breaks OCP itself.
Shouldn't be there in the first place.
Or you're fixing a bug.
In fact, you could go ahead and just break that out into, just make an input handling class or something.
Well, I would probably use a command system to do that. I would just end up replicating what we had before with the I command.
Yeah.
Which I command
rather than every time you were trying to explain it, you had to make that caveat, and it's probably confusing to someone.
But the idea is that this class is closed for modification but open for extension. We can extend this object not through inheritance but through composition, where we can add additional rooms to it. Another example of OCP would be the command system that we have. The command system that I put together, like I said, I particularly like because it really breaks apart our logic. Each one of these commands is a specific nugget of functionality that can be reused in other cases. And the only time that this functionality will be changed is if I find a bug. Well, Wolf, imagine remember how I said before, imagine adding a new room to this class. Adding a new room to this class would require adding an enum option, adding a new case statement, adding a new else if, and adding a new method. That's going to be very, very problematic. This code, to add a room, all we have to do is write a class that implements the iRoom interface and pass it into the addRoom method. This class is built upon the iRoom abstraction and allows us to add additional rooms of any functionality that we desire without modifying the class itself. So as a result, this class is incredibly more robust, much easier to use, and is it's a lot harder to cause bugs in this class.
Just take notice of where in code in each of the two examples you are actually adding rooms, because that's the most obvious point. In the original, in the bad game, in the game way of doing it, you are actually doing it inside the actual game itself.
Right.
Which means that that game can only do that.
And if you
if you want it to do something else, you have to actually go in there and change that. Whereas in the good game way of doing it, none of that's happening. You have a way to add things in the class, i.e. the ability to add them to the dictionary. But whether or not you do is done elsewhere in code, in this case in your main method.
Yep.
In program. It's not even in the same class,
So as a result, this is an example of a class, again, that is open for extensibility but closed for modification. And this is also supposed to, I really want to drive home the fact that if you talk to another programmer about OCP and they mention inheritance, be sure to slap them really hard across the face. Because OCP does not, although you can properly write code that follows the OPC principle by using inheritance, that's not the only way that you can follow the principle. The principle is more of a concept than specifically using one particular language feature to solve one particular problem. The entire .NET library, the entire C# language is available to you to solve this problem. And the problem, again, is that the problem isn't that we're not using interfaces. The problem isn't we're not using inheritance. The problem isn't that we're not using reflection or generics or dynamic typing or implicit typing or any specific language feature. The problem is this code is bad because it requires a lot. It's a very high maintenance class that will require modification upon every new bit of functionality we wish to add to it, and it will exponentially increase as the class gets larger the potential for breaking the entire class and destroying the program and causing the end of days. With the other class, the good game class, what we have here is we did use interfaces. So we did use a language feature, a specific language feature that we've been talking about, to solve the conceptual problem of having a rigid class. So as a result, what we have now is a very flexible class that can do many things without being modified. And another example of OCP is our command system. Our command system is a way that we can represent OCP because every time that we want to add a new feature to our game, we add a new command. And the only time we go in to modify existing code, existing commands, is to fix bugs. I mean, that's not necessarily true. Maybe we have a we'll decide that we want to change the way that we're saving a game and loading a game. So maybe we would modify this code to make it so it saves and loads in a different way. But that's more of a bug.
It's a different sort of, that's somewhere where you want that one change to take effect across everything. It's not the same sort of thing as going in there and adding any new functionality.
Yeah, it's changing existing functionality. And you generally can't change existing functionality without, changing it. But the great thing about great thing about OCP and SRP combined, they go hand in hand. This class follows SRP very well. If you remember from last week, SRP is a class or a method should only have one reason to change. And OCP, again, is that classes should be closed for modification, open for extension. those two things aren't mutually exclusive. This class may have to change because we might want to change the way we load our game, but because it follows SRP, it's not a bad class, because there's only one reason for this class to change. And my engine class hasn't changed really at all since I wrote it. It's been pretty much the same thing, because all it does is it's the state manager. That's it. The game class, my game class hasn't changed. It doesn't need to change. The game class is basically just a dictionary of game objects. That's all it is, and a player. My switch date command, no reason for this to change, because it does what it needs to do. Start game command, again, no reason for this to change. And if I were to add a new feature to the program, I could do so by adding a new command, by adding code. Write-only code is a very, very important concept. And by using interfaces properly, we can do write-only code, because all we have to do is write a new class that follows a specific interface, and then we can plug it into any bits of our existing code that understands that contract. Musuru,
and if, for instance, you
what?
I was going to say, if, for instance, if you came back to your game and suddenly said, okay, rooms, there's something, we've decided that as part of the game there's going to be a huge earthquake and some of the rooms get destroyed, so rooms now need to be destructible, for instance. What was I trying to say? Wow.
Okay, so continue on, Nelson.
I had another example and it went in the midst of trying to say it. So yes, carry on. Any more questions on?
Well,
anything more you wanted to cover on?
Yeah, like for example, if right now I have a basic room class that's just room, and all it is really is a collection of room connections, items, a name, a description, and a type and an ID. It's pretty much all it is. But because I'm hiding it behind an interface, what I can do is that I can create a new room class that has a new feature in it. So, for example, you might be tempted to, let's say you have a room class that has a, you want to make a room inaccessible after X amount of time. Now, one very, very tempting way to do that would be to add functionality to the room class, say public date time destroy at. That might be a very tempting thing to do, but that's not what you would want to do. You have two options to implement this feature in a way that's appropriate. The first option is to create a completely new room class, and that's a completely valid option depending on what you're going for. The second option is to actually componentize, and I'm not sure if that's a word, but I just made it up and I'm going to use it, a room into different sets of features. So, for example, you could genericize the idea of a room as just being a collection of, let's say, name modifiers. It's like what I did with the player weight. A player has a... where? My player ran away. Oh, there he is. My player has a carry weight. And the carry weight is calculated by looping over every single item in his inventory, checking to see if it's an iCarryWeight modifier, and then invoking the iCarryWeight modifier .modify carry weight method. So in this way, I provide the ability to modify the carry weight of a player without actually modifying the player class at all. All I have to do is create a new item that implements the iCarryWeight modifier and add it to the player's inventory. So that's another example of OCP. And here's one thing about OCP. You might not know at the start of your project what bits need to be added to your code to make it follow OCP. You may have to do refactorings. Like with this code, you might start off with a game class like this. And you might start off with other classes that break OCP because you don't foresee any instances where it'll become a problem. At that point, that's when you step back and do a refactoring. You ask yourself, how can I represent the same logic in a way that's a better design? And that's what the core of a refactoring is. And that's completely valid to do. You won't get strange focus bugs if you don't use GoToMeeting.
And I don't know,
you'll
probably...
You what?
I was going to say, I don't know what your reaction to this will be, but I often think when you first come to this idea of, right, how do I now go from the spaghetti sort of code that I'm used to writing to a better sort of refactoring of it, a good place to start looking is anything where you're doing something very specific. Like, for instance, here, like Nelson has said a few times, the console, the writing and input getting stuff really shouldn't be there.
Right.
Because it's doing a specific job that really doesn't relate to the room, the rest of what the room is about.
Or the rest of what the good game class is about. The good game class shouldn't be really dependent on input code, because input code can change very easily. This should be broken out and separated. Okay, are there any questions about... And did I cover the basic idea stuff? When does the open-close principle take effect? Ship date, when the other developers are working on your code. Like all design principles, it doesn't take effect as much as it's always there looming over your shoulder. And remember, you have to decide what your abstractions are. If I were to write a good game class that can do anything, I would end up writing my own programming language, by definition. If I can make this good game class so flexible and so abstract, not only would it not do anything, but to instruct it to do something specific would be as complicated or even more complicated than literally handwriting the intermediate language myself. You have to choose your abstractions. You have to say, okay, I want to, this bit I see happening over and over again. Like a code smell would be, a code smell should be, I am modifying this class a lot whenever I add functionality. I need to refactor this. So then you would refactor it. And that would be a specific thing that you refactor. You wouldn't be making this game class, like I said, so flexible it could do anything. Because like I said, per definition, you would end up with a programming language and not an actual program.
And hopefully people are starting to see as well, this is where how you format the code can really speed things up. This is why we hammer on about formatting code properly. Because straight away when you look at this game class, you can see where redundancies are occurring.
Yeah, the 3 instances
because
are immediately
there's
obvious.
Chunks of code that are line by line the same thing happening. I mean, it's particularly obvious here because of what the room IDs are and the fact that they all happen to have the same length of number of characters in them and stuff, so it all lines up perfectly. But again, in the if statement, you can see if part something equals something, current room equals room ID dot something. Repeated over and over again, and it jumps out because of the formatting. If you had random formatting and spaces and oddities in columnation, you wouldn't necessarily be able to, and this is quite a simple example, but you know, when you've always got to remember that these are simple examples of individual things, which is not how you will in the real world come across. But you know, it's very rare that because like a lot of the 101 programs that we wrote are basically come down to a method somewhere in a library that somebody's written already.
Yeah.
You're going to be working on stuff that does more complicated, or more things, not more complicated things, but just more things.
Right. But at least as far as just finishing up with Rowdy Bull's question, you want to incorporate good design, and working on OOD is really an investment. And it's an investment in the sense that it takes time and effort to conceptualize, to identify, and to code something that would be a proper design compared to just tossing code at a screen. What you learn at, working as a developer is when to at what point do you perform the refactoring? At what point do the code smells get so obvious that you realize that spending a few hours fixing a design problem is going to save you considerable amount of pain in the future? And even I do this, and every developer does this, and they do it more often when they start out and less often as they get more experienced, but you might go one or the other way in the wrong direction. You might either spend too much time, abstracting things, making things perfect, or you might spend too much time or too little time abstracting things and making things good. And it's really a balancing act that that's something that is intuitive and something that will change completely on every different project that you are on, has entirely different constraints and entirely different requirements as to how your code should function and how it should be designed. So there's no easy answer to your question. However, it should be before ship date. You should be doing this before ship date.
I mean, really, you should, yeah. You should be doing this before you open Visual Studio. While it's booting up, you can be thinking about what form you want to use for your...
Right.
What would be the best structure, the best, because these are big principles. These are overriding architectural and strategic principles of how to code.
They're primarily there to identify code smells. They're primarily there, once you learn these principles, take them to heart, you should be able to look at code and say, this follows this principle, or this does not follow this principle. And that will allow you to focus on the bits of your code that need the most attention as far as design. Like how I said, this bit still violates OCP. Not as bad, because the input code is going to change much less frequently than adding or removing rooms, but it still does violate that principle. This is smelly code.
And again, I keep harping on about this, but it's just gone past in BuzzNet again, and I want to add to it. It's all about practice. You've got to do it. And actually the best analogy is like learning to drive. When you first start learning to drive and you're first out in a car, you have to think about everything you're doing, literally down to how far away the stick shift is, how hard you have to pull, where the brake point is on the clutch. Obviously I'm talking to people who properly know how to drive. But as opposed to once you suddenly reach a point where you can have a conversation with someone else in the car whilst you're driving.
Right.
Anyone who's been driving for any length of time knows that experience of getting home and not having the faintest memory of the journey, because it's automatic. It's become part of it, and that only happens through practice. And exactly the same is true of this. You might still not see what exactly is wrong with this piece of code, but the more you do it, you'll find that you pick up. It might be one or two different little things that you do differently in each project you do, but gradually your code will start to look more like good game than game, just habitually, because...
Yeah, you'll start to get...
Well, actually, a lot of these things do come down to the fact that you are getting rid of repetition of code, you're getting rid of specificity of operation, so that you're making things more reusable, and consequently that it's almost a function of writing less.
Yeah.
I think I facetiously at the end of 101 summed up your coding style as writing less in more files, writing fewer lines of code in more CS files to do things quicker.
Right. And eventually this code will cause your eye to twitch. And yeah, so that's pretty much what Gavin was saying, is identifying these things become very easy. Okay, so I just want to know if I'm doing this the right way. For example, is the way I have save file state.cs written good or bad? Is it? I mean, save file state,
actually, NATO probably nailed down the problem that most people are nearest to having. He said, see now, I can tell that game is bad, but good game is just kind of confusing still. That's exactly how I felt when I first was presented with all of this. which is it's the source of my ragging on Nelson about just the sheer number of files in his projects. You look at it and go, oh my god, there's 1,000 things in that Solution Explorer.
Right, and when in reality there's not a whole lot more code, but it's organized, it's separated out. And it allows for write-only code, which I really like that term, write-only code. So as far as the save file state, the save file state has really two responsibilities. Well, not two responsibilities in the way that, it buys you food and cleans your house, but two responsibilities in that which you could say is a single responsibility quite easily, because it prints out the user interface and accepts user input. The and in there is a very, very faint and. So that's all it does, and it can do that in as many lines of code as it wants, as long as it just fulfills that one responsibility of getting the user to select a file. And then when something happens, when the user describes his intent to the state, then the state delegates to different bits of code in order to perform logic. So the state itself does not have any logic other than other than input handling. That's all it does. And then once it gets the input from the user, it defers the responsibility of actually performing the action to another object. So for example, if we type in back, we switch to the last state. If we type in save, we save a game command. If we don't type in anything valid, we get an invalid command.
Which is why you often see, I've seen it quite a bit recently in descriptions of this, that it says it enables, what's the phrase always used for the official definition of this? Because it makes it look like it's changing into a different type.
Polymorphism?
You know the phrase I mean? I mean literally. They say it enables you to. It's the Gang of Four description of the composition. It enables your class to do different things. It enables it to look like another class.
Well, in the sense that...
Okay. I assumed you would pick up on that. You've said it enough times, but...
Well, it defers responsibility. It delegates responsibility. Is that what you're referring to?
Not exactly, but carry on.
Okay, so any more questions about this discussion about design? And are people understanding this? Are people feeling good about what's been covered? Because this is a very, very important principle. That, again, you might be talking to somebody else, or you might read online a description that says, ooh, make all your classes inheritable, make all your methods virtual, and I just want to punch them in the face, because you do that and you introduce a lot of problems. A lot of problems. Specifically, you will end up destroying the Lipskov substitution principle. And I can never get his name right.
Lipskov, isn't it, I think? But yeah. And Wolf, yeah, that's kind of exactly where you should be at the moment. Because, like I said, that's what I meant. It comes with practice, and you won't suddenly wake up one day and write code like Nelson's, as opposed to writing it the old-fashioned way, for want of a better term. It's a change over time. A little bit at a time.
My problem was all my logic was in git command. The git command should only be responsible for establishing the intent of the user and then delegating the actual processing to a separate object. In that way, not only do you get separation of concerns and follow SRP, but you also create a reusable save game command that can be executed from within any point of your system, not just necessarily the save state. Okay.
Cool.
Yeah.
Homework
is going to be hopefully very easy, because at this point you should have a room state where you can actually hold on. How much like Nelson's code are you expecting from us at the point regarding homework? Because my code is similar enough to be encouraging, but different enough to be terrifying. I've said this before. I really want people to write implementations of this game that make sense to them. And I want there to be parts that don't necessarily make a lot of sense to them quite yet, because otherwise you wouldn't be necessarily pushing your understanding. But it doesn't have to be.
It's important that enough of it, you understand the specifics, or sort of you understand that why you've written something and why you want something to do something. If you happen to have made it do that something in a way that is not necessarily like Nelson's, that's, in a way, it's less important than that, because, as I say, it comes with time. The more coding you do, the more you will start to tend this way, just out of habit and out of... It's easier to do it this way once you get your head around it.
Well, yeah, and if you guys can get to the end of this class with a functional RPG text game, and it does, and there's an obvious use of good design principles within it, then I'm happy. Obviously, the code that I'm going to be writing is going to be code that I would have written if tasked with getting this game, with the exception of not being able to use certain features of the language. But the idea is that you walk away with a functional game in a decent design. And, you know, even more importantly, a fun thing to do, a really cool thing to do actually, would be after this class, delete your entire project. Just nuke out everything that you've written during the course of the class and recreate it as much as you can, not from memory, but from understanding. And a game like this, you know, once the actual gameplay is identified and everything is straightforward, at that point, you know, rewriting the application should only be a matter of a day, a few hours. And that'd be a really good experience. How do we connect the rooms? The way that I connected the rooms is that my iRoom interface, I have a class called Room Connection, and my Room Connection class has a room iRoom property and a direction string property. And in my room class itself, my basic room, which I can't find because I didn't name it basic room because I'm stupid, I have a method called connect room that adds a new room connection object to my connections dictionary. And then inside of my game factory, and my game factory, again, all this is a single method. This is just for the for creating the initial map. So the fact that it's called game factory, I'm not, you know, actually doing, you know, the abstract factory pattern. It is the factory pattern, but it's nothing really that amazing. All this does is instantiates a new game and creates all the rooms. So you'll notice at the end I say things like cryo.connectRoom north to engineering, engineering.connectRoom north to bridge. And that what it does is it instantiates a new room connection and assigns it to the room connection list dictionary.
Does presumably that also ought to also create the relevant connection from the other room in the opposite direction?
Nope, not necessarily. And that allows for one-way room entrance.
Okay, just wondered. But where to what? Okay.
And also, I'm using a string instead of an enum.
How does that work? Surely that's like a bricked-up door. And you've got a door that's you've got. Okay.
Like a portal. Like, because my connections are with
Yeah.
strings.
Okay. No, I can see what you're like. If you sort of fell through the floor or something.
Yeah.
You couldn't get. Yeah. Okay. Just threw me slightly.
So yeah. Okay. So homework basically is going to be allow the user to move from room to room. So by the last class, you should have had a state that represents a room. So now you're going to have to write code that can allow the user to type in a command that will transition him to another room. So you're going to have to do two things. You're going to have to create a room. You're going to have to work on your room type a little bit and allow for the concept of a connected room to exist. The implementation I chose was the most straightforward that I could think of, where I would have a list of room connections. And again, instead of IEnumerable, you would have a list here because we haven't gone over IEnumerable yet, but we are going to be going over IEnumerable in this class. So I have a IEnumerable of room connections and then a getConnectedRoom method that returns an iRoom or null. So yeah, and then you just basically put together a room state that can transition into another room state, depending on which direction the player moved. The room connection class is, all that is somewhere. There it is. I don't know how it ended up in my GameObjects namespace. The room connection class is just an iRoom and a direction. That's all it is. So, again, possible implementation. This is a possible implementation. All I want to see is people being able to move from one room to another. How you implement it's up to you. Here's one way that I implemented it.
Yes, because I mean, it would presumably be an equally valid approach to have each room have know what its neighbours are, essentially, for certain sorts of game. It also is all kind of rather dependent on what you're going to be doing.
Right. Okay, so is that clear for everybody? So NATO, basically allow for the user to move from, like for example, allow for the user to say, move north, and actually move north, and then move north again, and then move north again, and then move north again. And well, obviously you would probably want something like, let's say, engineering connect room south to cryo.
Yeah, you see that.
So I can say move north, and now I can move south. The homework for presenting a room to the user was this last week's. The homework for moving between rooms is this week's. And definitely show up on the open office hours if people have questions.
Yeah, for sure.
Yeah, we need, presumably, we've been going for, coming up on 4 hours now, I think. So we probably need to look towards winding this up.
NATO, every time that you rewrite this application, you will have a better understanding of the code.
Yeah, I thought you say, I think I've broken my code anyway. I was going to say, excellent, that's a good chance to go in there and fix it and make it better. Yes, this is week 4. It just happens to be week 3 on that list because we split week 1 across 2 lessons.
Okay. So is that it?
Yep. Let's go ahead and wrap things up, and we'll see everybody at the next open office hours, hopefully.
Yeah.
Cool.
So goodbye.
All right. Thanks, guys.
Everybody.
Thanks, guys. You guys have a good night. Bye, everyone.
Bye.
Bye.